Are those lines on the red plain the handwriting of a mind, or the grooves carved by indifferent rocks? That question arrived like a cold light, simple and unforgiving. It did not ask for gradual assent or a measured shrug. It demanded a reorientation of scale and certainty. It unfolded in headlines, in the quiet hum of laboratories, and in the thin, private thoughts of millions who looked up and felt suddenly less alone, or suddenly much less sure of what they knew about their place in the universe. The image itself was ordinary in one sense, a sweep of ochre and rust, ridges and shadows traced across a barren plain. Yet within that sweep there were angles that preferred geometry to chaos, arcs that hinted at repetition, regularity that refused to belong to sheer randomness. The shapes seemed to hold a gaze back at those who looked. This opening question, natural phenomenon or alien artifact, is not new. It is ancient in the human imagination, a recurring motif whenever the unknown arranges itself into patterns that press against the borders of explanation. But the venue had changed. What once could be dismissed as a grain of sand mistaken for a god now required a different kind of suspension. The suspension of scientific norms when images and data insist on speaking in a tongue that is almost, but not quite, familiar. The wonder came first, and with wonder came a vexing intimacy. Observers felt a kick in the chest, an almost physiological response to the geometry of the Martian surface. There is a peculiar human urge to map meaning onto lines. The brain, honed by millennia of reading faces and reading landscapes for shelter and threat, leans towards story. It saw corridors and courtyards, the ruins of walls, the broken ribs of architecture frozen mid-collapse. Yet alongside that impulse was a colder voice of caution. Pattern-seeking is a survival mechanism, not an arbiter of truth. The mind that whispers civilization is the same mind that once read canals into shadows and projected entire ecosystems onto a planet that, by every measurement, seemed hostile and thin-breathed. What complicated the question was how modern instruments translated what the eye could no longer settle. Cameras orbiting the planet sent down meshes of data, high-resolution mosaics, elevation maps, thermal imprints, spectrums of reflected light. Each modality offered a different story. Viewed in visible light, a formation might suggest parallel ridgelines broken by perpendicular scars. Viewed in infrared, those lines could melt into temperature differentials that argued for compositional variety, different minerals laid down by the slow chemistry of water and wind. Radar whispered secrets about subsurface echoes. Sometimes those echoes suggested cavities, hollow regions that made the heart of the formation ring like a bell. Yet even as instruments multiplied, uncertainty compounded. Instruments have their own blind spots, their own tongues for translation. When several instruments sang in harmony, the case for something anomalous strengthened. When they disagreed, the discord amplified suspicion. A particular kind of feeling attended these moments of disagreement, vertigo. It was not the dizzying, picturesque vertigo of standing on a cliff overlooking a gulf of stars. It was the vertigo of possibility and erasure, of imagining an answer that would rearrange not just knowledge, but the grammar of history itself. The thought of an intelligence that had left enduring traces upon another world touched something intimate about longevity, mortality, and the fragile ways in which memory is made durable. Conversely, the thought that ordinary geology could mimic the grammar of design reminded humans of their own epistemic frailties. How swiftly a civilization's traces can be worn away by wind, water, and time. The gaze that met Mars from Earth had changed over centuries. Once it was a romantic projection, canals and imagined cities drawn by wishful hands. Now it was a disciplined, instrumented attention that nonetheless carried with it the heritage of those early imaginings. That heritage mattered. The stories that predated the technologies left marks on how data was interpreted. When a pattern appeared, part of the cognitive machinery that processed it had a playlist of narratives ready, some consoling, some grand, some dangerous. The modern gaze was thus a composite, part optics and algorithms, part cultural sediment, all superimposed on a geological surface that had its own slow, stubborn logic. To speak of the gaze is to talk about more than sight. It is to consider how humans look, what they bring to looking, and what the act of looking does to the world under observation. Looking is an act of violence and also an act of care. It reshapes the stakes of the observed. Cameras turn toward a place that was once indifferent to attention. Deserts have no wishes, but deserts respond to being named. The very act of labeling certain features as structures or anomalies changes the epistemic landscape. Funding flows. Old theories gather dust. New teams assemble. This is not merely bureaucracy, it is the social life of attention. The way collective focus can elevate a whisper into consensus or leave it to the loneliest corners of speculation. There was a palpable human need to inflect the unknown with urgency. If Mars held artifacts, the implications were breathtaking. The possibility would force an accounting of human history against a broader ledger of intelligence. It would also demand new ethics, how to investigate without destroying, how to recognize agency where agency might not want to be known. But even the act of entertaining such possibilities revealed something quieter, more intimate, a longing to bridge eras, to find a continuity that exceeds species and planetary boundaries. Human beings, facing their own fragile longevity, search for proof that memory can outlast catastrophe. The structure on Mars could be an answer, or a mirror. Yet other, more restrained currents of thought did not want to leap to narrative. There was a repertoire of natural processes that could emulate the ordered beauty of design. Aeolian sculpting, wind-driven erosion, arranges layers with a patience that seems almost deliberate. Thermal fracturing makes near-linear breaks. When water once flowed, it could leave terraces and channels that, from above, read as limbs of a plan. Lava flows, too, can create polygons and geometric regularities when they cool and contract. Even the mathematics of sedimentation and mineral deposition has a proclivity for regularity under certain constraints. The planet itself is a long experiment in physics, offering up patterns that are lawful rather than intentional. To weigh these possibilities required a new kind of patience. The initial emotional charge, the gasp at an image, the conspiratorial thrill of possibility would need to be tempered with method. Data would be rerun, models adjusted, analog experiments performed. Laboratory chambers would simulate Martian thinness and cold, testing whether freezing and thaw cycles could coax rock into right angles or fold planes into repeating bands. Statistical methods would be brought to bear. How often do such formations arise in randomized landscapes? What degree of regularity counts as meaningful when viewed at the scales of kilometers? The distance between an artist's eye and a geophysicist's check might be bridged by mathematics. Yet even numbers carry their own narratives when read by different communities. Alongside austerity, there were other, subtler human responses. Wonder begets creativity. Musicians wrote pieces that tried to render the image in sound, long ascending lines interrupted by sudden percussive knocks, as if a tectonic instrument had been struck. Poets used the geometry of the formations as metaphors for relationships, parallel lives, intersecting trajectories, the hollow spaces between constructed intentions and the Earth's indifference. The image inspired not only scientific inquiry, but a cultural cascade that turned a geological question into a question about meaning. That cascade itself changed the debate. Once culture had placed the idea of alien-made structures into the realm of products, songs, essays, think pieces, it became harder to treat the question as purely technical. Public longing can, paradoxically, both illuminate and muddy the path to truth. There was also fear, not the cinematic fear of invasion, but a quieter dread, the kind that slides under the skin during long nights of reading. If something else had been here and left traces, what had happened to it? The erosive hand of time is not a tidy thing. It sweeps away monuments and names alike. The possibility that intelligence can be ephemeral, brilliant and quickly erased by cataclysm or slow attrition, suggested cosmic solitude, civilizations that burn and vanish without leaving durable messages. That prospect made the stakes of terrestrial preservation sharper. If traces on Mars could disappear in geological breaths, then the memory of human endeavor on Earth might be even more precarious than imagined. The decision to look, to scrutinize particular formations with extra scrutiny, set off a choreography of instruments and minds. Orbital cameras adjusted their scanning priorities, beaming higher resolution strips that revealed texture, grain sizes, fracture orientations, layered sequencings. Synthetic aperture radar probed beneath surface dust for the geometry of buried strata. Spectrometers passed chemical fingerprints, seeking the telltale signs of construction. Alloys, processed compounds that are not readily made by natural geochemistry. Each new dataset was another voice in a polyphony. Some voices echoed the naturalist reading, composition consistent with basaltic flows, crystals aligned in ways consistent with cooling, patterns that could be replicated in terrariums. Other voices held open the possibility of the anomalous, localized concentrations of non-random metallurgy, alignments that persisted across modalities, echoes of internal cavities shaped in ways that invited interpretation. What framed the debate was not simply the evidence itself, but the human orientation toward evidence. Scientists, by training, sought the most parsimonious explanations. Yet the human imagination is not bound by parsimony alone. It also organizes possibilities into narratives of continuity and rupture. That tension between parsimony and the hunger for a larger story is where the drama lived. The scientific method acted as a tether, but curiosity pulled in all directions. The dare was to remain rigorous while allowing for the truly surprising, the anomaly that sometimes becomes the seed for a revolution in thought. In the background of all this calibration was a deeper, quieter theme, the relation of deep time to fragile memory. Earth itself is a palimpsest. Entire chapters of its surface record have been overwritten by oceans and ice and fire. Humanity's own earliest constructions have been consumed by time's appetite. The possibility that another mind had once inscribed its presence on a planetary surface, and that those inscriptions still persisted, in some form, tacked into a longing to anchor memory beyond the tenure of any single species. Whether or not the structures on Mars were authored, the long game of preservation, of creating durable records that can outlast geological forces, forced a re-evaluation of what survival might mean across epochs. The gaze, then, was not only outward but reflective. Looking at Mars forced humans to look at themselves, their methods, their biases, their hopes, and their fear of being alone. It was a lesson in humility and in the persistence of wonder. For every data set that argued for geology, there remained an unquiet room within human thought where the possibility of intelligence could not be fully closed. For every cautionary note, there was a counterpoint of wonder that insisted on keeping the question alive. And so the question hung, not as a cliffhanger in a novel, but as a methodological hinge in the life of inquiry. The formation remained, orbiters continued to pass, instruments slowly spoke in different registers. A human response unfolded in stages: initial gasp, careful analysis, cultural ripples, ethical speculation, renewed caution. Each stage revealed different aspects of the original question, were the structures natural or deliberate. The answer would not come as a single pronouncement, but as a slow accretion of evidence and perspective, tempered by the hard reality that time and processes can mimic mind in ways that satisfy our pattern-hungry cognition. In that way, the Martian question became a mirror for terrestrial thought about deep time and forgotten histories. The planet's lines were a prompt. If intelligence can leave marks that appear architectural to distant observers, how should humanity read its own ruins? How does one search for voices in the sedimentary record without mistaking the geometry of erosion for intent? The problem is both scientific and philosophical, because it asks not only what is visible, but how visibility itself is interpreted in the shadow of loss. The initial shock of the question has a function. It opens a crack in habituation. It compels attention not simply by novelty, but by its capacity to unsettle assumptions. Whether the lines on Mars were ultimately explained as wind-sculpted ridges or as vestiges of a bygone intelligence matters less. In the short term, then, the way the question reoriented inquiry toward humility, toward a more reflective practice of looking, toward the crafting of methods that could, when needed, carry the weight of extraordinary claims. The human gaze had been trained to seek patterns. Now it had to learn to read patterns with an eye both skeptical and receptive. At the edge of that tension, between eagerness and restraint, between wonder and method, the narrative of exploration deepened. The planet remained mute, indifferent to the human voice that addressed it. Yet in the silence, the act of looking had consequences. It altered where attention flowed, what resources were allocated, which metaphors became live. The question continued to circulate, natural or designed. It was both an interrogation of Martian geology and an introspection in which humanity measured its own appetite for significance. The coming investigations would not only map a surface, but also chart the contours of human hope, fear, and the perennial urge to make contact with continuity across the cold distances of time and space. What does a line drawn by human sight become when it travels across a century? Is it a sentence in a forgotten language? An echo of a thought that never was, or simply the way light and shadow conspire to trick an eager brain? That question about lines and the minds that read them arrived first, not from a rover or an orbiter, but from the patient, complaint-free glass of 19th century telescopes. It arrived as a translation error, and as a conviction, as a single Italian word that would travel into myth, canali. From Earth, through the long-stilled lenses of an earlier age, the red planet offered its humble geometry and invited storytelling. The image that observers carried from eyepiece to drawing board was always partial, a smear of light, a band of dark, a suggestion of edges. Telescopes in the 1800s were instruments of transformation, brass tubes and polished mirrors that turned the remote into the intimate. They did not merely magnify, they choreographed perception. In rooms scented with warmed brass and oil, under the hush of night and the soft scratch of pencil on paper, astronomers trained their eyes until the subtle became legible. It was Giovanni Schiaparelli who wrote the word that would tilt public imagination, canali. To his precise Italian mind, it suggested channels, features shaped by some natural flow. But in translation, and perhaps in desire, canali became canals, intentional, engineered, a system of waterways that implied planning and purpose. Percival Lowell, with a flair for narrative and a hunger for cosmic companionship, propagated that reading. He sketched maps, he wrote books, and he gave an entire culture a story to carry home. There were roads on Mars. There were artifacts of mind written in its plains. The 19th century canal fever was not merely a mistake in linguistics. It was a psychological phenomenon. Humans are pattern-hungry creatures. The brain is an organ built to make stories from fragments, to bind seams where none were sewn. In the candlelit observatories, observers felt the thrill of discovery, the low, steady drumbeat of something that could include them in a larger, longer history. Some nights the lines on the glass suggested order, other nights they resolved into randomness and were faithfully redrawn as smudges and scribbles. Still, once the idea moved out of the observatory and into newspapers and lecture halls, it grew teeth. The public wanted more than maps. They wanted meaning. It was easy, in that age, to cross from cautious scientific curiosity into full-throated conviction. The instruments of Sutton and Clark were magnificent for their day, but they were also limited. Atmospheric turbulence, optical aberration, and the simple fallibility of human vision all conspired. An atmospheric ripple could straighten into a line at the right moment. A shadow could become a corridor when the angle of sunlight shifted. Yet the social machinery of interpretation lectures, illustrated journals, salons where scientists rubbed shoulders with poets, fed a narrative appetite that replaced doubt with drama. There were moments of fervent certainty. Lowell, standing in his Flagstaff Observatory, spoke in a voice that blended wonder and near evangelical zeal. He described channels that suggested a dying planet, a civilization that had to manage dwindling water with great cunning. His prose turned observation into story. Where Schiaparelli's canali hinted at possibility, Lowell's canals insisted on a history. In public reading rooms and coffee houses, people debated not just the existence of canals but their moral narratives. Who had built them, what they had meant, how they collapsed. The canals became a mirror for human anxieties about empire, decline, and resilience. Those debates mattered. They shaped funding priorities for telescopes and spurred voyages of imagination that reached beyond the limits of current instruments. They were also a cautionary tale about the distance between perception and fact. For decades, the lines mattered more for what they revealed about humans, how they see, how they hope, than for what they revealed about Mars. Then the age of the spacecraft arrived, and with it the capacity to answer the old question with a new kind of clarity. The shift from earthbound telescopes to probes and orbiters was not a single rupture, but a slow gathering of technological confidence. A handful of decades changed the nature of what could be known. The probes that skimmed past Mars in the 1960s and 1970s carried instruments that did not argue in impressions but in photons and radar echoes. They recorded terrain with a dispassionate precision that no human eye could match through an eyepiece. The first Coe's views dissolved the romantic economy of canals into familiar geology, cratered plains, weathered rocks, dried riverbeds whose arcs told stories of water long gone. For a generation raised on Lowell's maps, the spacecraft's photographs were a kind of grief. The lines that had suggested intention were, in many cases, the work of natural processes, wind-sheared ridges, deposits of darker basalt from ancient flows, the interplay of light and slope. The Mariner and Viking missions, and those that followed, revealed a planet whose language was geophysical, not grammatical. The instruments could measure composition, detect subsurface layering, and trace the faint signatures of ancient fluvial activity. The romance of canals gave way to the sober, almost austere poetry of planetary processes. Into this transformed landscape stepped Marin. Marin was not an evangelist for lost civilizations, nor a zealot for purely geological explanations. Instead, Marin embodied a different tension, the tension between human narrative and instrumented fact. In the control rooms and analysis suites where Marin worked, images arrived as raw data numbers, levels, spectral curves, then had to be coaxed into meaning. Marin's work was interpretive labor, the patient knitting together of models and metaphors, of error bars and intuition. Marin's inner life was not a dramatic torrent, but a series of quiet reckonings. There was an initial reflexive fondness for the canal story, an inherited cultural itch. Marin imagined, for a moment, ordered lines and the hands that might have drawn them. But then, reading a spectral map at dawn and watching the planet's colors shift under different filters, Marin moved from fancy to method. The mind's appetite for narrative remained. Marin learned instead to bridle it, to let story be provisional and hypothesis be provisional too. Colleagues spoke to Marin in the clipped, earnest cadences of scientists at work. One of them, a specialist in imaging, said quietly while they pored over a new narrow-angle strip, "Look at the grain structure here. See how the reflectance spikes where the slope angle changes. It's telling us about fragment sizes, not about architecture." Marin answered, not defensively, but with an openness that could seem almost confused until the listener saw the precision behind it. "Yes, but why do these lines prefer straightness over curvature at this scale? Isn't that odd?" The exchange was small, the words ordinary, yet it encapsulated a human predicament. The mind cannot help but ask for cause when it sees regularity. What mattered were the tools and how they reframed possibility. Where 19th century eyes contended with blur, 20th century instruments brought resolution. Synthetic aperture radar could strip away dust and reveal buried geometries. Topographic mapping could trace gentle scarps and plateaus with centimeter precision. Spectrometers could name minerals by the way they scatter light, pointing toward aqueous histories or volcanic pasts. These modalities did not merely add detail, they changed the grammar of interpretation. Channels that had once read as deliberate were now seen as the signature of aqueous flows that cut through bedrock eons ago. Straight trenches were sometimes fractures, the consequences of stress rather than intention. Yet the age of spacecraft did not close the debate so much as redistribute it. New anomalies emerged. High-resolution images showed linear features that, to some eyes, kept their insistence. Radar returned echoes suggesting cavities, voids that raised the question of subsurface spaces. Spectral outliers hinted at mineral concentrations that seemed localized and non-random. Every instrument carried both its promise and its blind spots. A sensor designed to detect iron-rich minerals might miss delicate organics. A radar sweep could suggest a hollow, but not disclose whether that hollow was the work of molten flow or of something else entirely. Interpretation became an exercise in triangulation, in the slow layering of independent modalities, until a consistent narrative rose like a sculpture from the clay of data. Marin watched those echoes the way one listens to an ensemble finding harmony. Sometimes the instruments harmonized. Radar, spectrometer, and topographic model all suggested a coherent explanation. Other times the instruments argued with one another. In such moments, Marin felt an old, vertiginous curiosity, the same quickened pulse that had led observers in the previous century to sketch canals with trembling hands. There was the thrill of possibly being wrong, the thrill of possibly being right, and the patient dread of the long process required to discern which was which. Dialogue in that room was not theatrical. It was the language of calibration. Run the spectral fit with the updated baseline. Can we schedule another pass at dawn? The sun angle will bring out the bedding. Model the wind transport over 5 million year timescales. These sentences were not dramatic lines in a play, they were incantations of disciplined curiosity. Yet beneath them lay emotion care, frustration, hope, the human register that feeds scientific progress. Marin's reflections often turned to the cultural afterlife of images, where Lowell's sketches had become myths, where newspapers had spun canals into metaphors of decline. Marin saw the modern counterpart, visualizations that could be misread, sensational headlines that could outpace facts, social media amplifying the ambiguous into the extraordinary. Marin felt a responsibility not just to the data, but to the public imagination, to translate without pandering, to withhold certainty when the instruments did. "We have to be careful with images," Marin would tell a journalist. "The human brain is great at narrative. Our job is to make sure we separate the tales we want to tell from the tales the data supports." That care extended to ethical questions. If lines on a map might once have been read as the handwriting of an intelligence, what responsibility did humans now have when they touched other worlds? Spacecraft do not simply look, they also alter through heat, dust, and sometimes contamination. The spacecraft age introduced a new ethic: how to observe without annihilating, how to study without contaminating, how to address the possibility of life, past or present, with humility. Marin felt those ethics in the small decisions: what landing sites to avoid, what sterilization protocols to demand, how to phrase press releases so as not to overpromise. The story that unfolded under Marin's watch was not the abrupt vindication of 19th century fantasies. It was, instead, a slower, more sober narrative of refinement. The canals, as imagined by Lowell, largely dissolved under sharper scrutiny. But the lines themselves, those arrangements of rock and shadow, remained interesting. They were interesting because they testified to processes that spoke across deep time, climates that changed, flows that ceased, ice that retreated. Their interest remained scientific and philosophical rather than mythic. They asked the living to consider durability and erasure. If water once carved a path on Mars, what did that imply about the planet's ability to host, or to have once hosted, the chemical precursors of life? Marin's private musings sometimes turned to Earth. Standing in the hum of analysis suites, watching a pale image resolve into a clear, geologically sensible form, Marin thought of human ruins buried on this planet. Forest floors hiding cities, sedimentary layers swallowing roads. The mind, trained to see design, often overreached. But the reverse is also true. The instruments, no matter how disciplined, could be blind to meaning that did exist because they were tuned only to certain signals. Marin held both perspectives with a kind of careful ambivalence. It was not that one was right and the other wrong. It was that truth required a mode of attention that could hold multiple possibilities simultaneously. That capacity to hold ambiguity became Marin's guiding principle. When a line on an image insisted on straightness, Marin did not leap to romance or to dismissal. The scientist mapped, simulated, and compared. When colleagues sparred, some proposing an engineering explanation for a given pattern, others suggesting a geological process, Marin mediated with datasets and patience. "We live with the discomfort of not knowing," Marin often said in internal briefings, "but we do not live without tools. Let the tools speak loudly enough, and then translate with humility." The transition from 19th century telescopes to spacecraft had been, in many ways, a lesson in humility writ large. The earlier age taught that the human mind will read purpose into order when it wants meaning. The spacecraft age taught that better instruments reduce certain errors but cannot remove the human tendency to narrate. The instruments, in their clarity, also highlighted the fragility of memory across deep time. Erosion, bombardment, and chemical transformation do not respect narratives. They erase. If the canals had been artifacts, they had been fragile ones. If the apparent linearities were geological, they were still testament to epochs that reshaped a planet. Marin's work, therefore, was not the cinematic moment of revelation. It was the steady labor of translation, turning photons into probabilities, images into hypotheses, possibilities into policies. That labor mattered because it reshaped not only what humans believed about Mars, but how they believed in the first place. It taught a generation of observers to prefer provisional statements and to treat wonder as a guide rather than as a verdict. At the end of a long night, Marin would sometimes linger by the monitors, watching a strip of terrain scroll past like a slow reel. In the soft light of the control room, the planet's surface looked less like a page of history and more like a palimpsest overwritten, rubbed, and replastered by the slow presses of time. Marin felt small before it, and also oddly consoled. Smallness was not defeat, but perspective, the recognition that the human appetite for continuity is noble and fraught, that memory across geological spans is both possible and precarious. The canal debates of the 19th century and the spacecraft revelations of the 20th were chapters in the same human experiment. The search for continuity and the struggle against misreading. Marin's role patient, skeptical, attentive, was a continuation of that experiment. The lines on Mars, whether the product of water, wind, or something else, remained prompts. They asked humanity to refine its tools and its humility, to develop methods that could distinguish intention from process, and, more profoundly, to cultivate an ethic of looking that honors both curiosity and restraint. In that way, the history of seeing Mars becomes at once a cautionary tale and a hopeful practice. It warns of the ease with which desire can masquerade as evidence. It also offers a path forward, one in which better instruments and steadier minds together reduce error and expand wonder in responsible measure. Marin, watching the planet from 1,000 kilometers above its surface or from a monitor in a quiet room, understood that the most enduring lines might be not those etched into stone, but those struck between data and doubt, between story and skepticism, lines that, when followed carefully, can carry human thinking toward a truer, if more complex, understanding of the cosmos. What does it mean to see a face where none was deliberately carved? That question arrived not as a slow argument, but as a single, stubborn picture a blocky silhouette on a distant plain that could be read as a semblance of eyes, a nose, a mouth. It arrived from a machine several 100 million kilometers away and, in the peculiar geometry of human attention, turned into an emblem of everything people wanted Mars to be, a place with history, agency, and a past that answered the loneliness of the present. In the summer of 1976, the Viking 1 orbiter transmitted strips of imagery back to Earth that would make the world squint. The image that would become the face on Mars emerged from the Cydonia region, a mesa seen under oblique sunlight, its shadows carving a geometry that, at the resolution then available, seemed to organize into familiar human features. On a screen in a mission operations room, the mottled gray pixels assembled into an outline that suggested recognition. The formation was not dramatic in objective terms, a small plateau among many, a scarp of basaltic rock, but the human mind leaned in until a face resolved. In the control rooms and reading bays where those first frames scrolled into view, the atmosphere shifted. The hum of tape drives and the rhythmic blink of status lights were ordinary. The arrival of a single strip of data was not. People who had spent years translating raw telemetry into maps and models chewed on it like a new hypothesis. They adjusted contrast and stretched histograms. They reprocessed the negative and printed it on glossy paper, letting black ink pool at the edges of shadow. In those manipulations, the face sharpened for some, softened for others. The same pixels that looked like cheekbones in one contrast scheme might be mere angled ledges in another. Marin, at that moment, not a mythical icon but an analyst in a room of steady work, felt a familiar tug, the mind's double nature. There was an immediate, almost childlike recognition, an impulse not of the scientist but of the spectator. Marin's pulse quickened briefly, the body remembering that pattern-finding was an evolved strategy. Then came the trained voice, cool and insistent. Do not speak in verdicts. Enumerate possibilities. Still, Marin could not entirely dislodge the private jolt of wonder. The thought passed through like a small light. If an intelligence had ever looked back, how would its mark read to a stranger? The public reaction was fast and ferocious. A press release that might otherwise have been a footnote became a story apparatus. Newspapers, hungry for a picture and a narrative that could be spoken about on evening broadcasts, printed magnified reproductions accompanied by headlines that performed certainty in the absence of it. Radio hosts read aloud the image's blunted shapes and asked their scientists live on air whether Mars had sent a greeting. The image, low resolution but intimate in its suggestiveness, entered the cultural bloodstream. The photograph, more than any spectral analysis or topographic map, offered a story the public could hold. That story quickly polarized into familiar modes of belief. Some reached for the extraordinary, evidence of an ancient Martian civilization, proof of intelligence elsewhere, confirmation that human curiosity had stumbled upon kin in the cosmos. Others moved to the opposite pole, skepticism that was not merely methodological but wary of spectacle. Scientists who worried about misinterpretation cautioned the media about parabolic leaps. We must remember, a scientific liaison said mildly during a televised panel, that resolution, sun angle, and surface processes can create illusions. The human brain sees faces where evolutionary advantage demands it. The line was both a technical observation and a philosophical admonishment. Those admonitions did not prevent a cascade of meaning. The face became shorthand for 1,000 narratives. It was read as an argument about loneliness, a billboard for pseudoscience, a cipher in conspiracy lore. Richard Hoagland and others wove elaborate threads around the image, connecting it to alleged alignments, sacred geometry, and hidden government knowledge. The formation's popularity fed a hunger for narrative simplicity, a single image that could compress complexity into a drama of discovery and suppression. The scientific response was in place, methodical, and sometimes weary. Scientists re-asked the fundamental questions. What is the role of resolution in image interpretation? How does sun elevation shape perceived form? Could aeolian erosion and tectonic fracture combine to make a mesa that, when seen from a particular vantage with a shallow sun, conjures the impression of eyes? The tools of analysis were deployed: topographic mapping, photometric models, simulations of light and shadow taken at various sun angles. The message was not that the face had been explained away so much as that the provisional explanation required rigorous testing. Within that testing was a demonstration of how instruments and human cognition co-author meaning. The Viking imagery was not flawless, but it was unprecedented. The imaging systems of the time captured good data under the constraints of bandwidth, storage, and sensor sensitivity. The consequence was an image that balanced on the edge of legibility. To the unaided human call of pattern recognition, the image offered enough structure to satisfy. To a scientist's analytic eye, the same structure begged for triangulation. It was a lesson in humility, how much of an observation's force comes from human desire rather than from the data itself. Years passed. Missions returned. As instruments improved, the face was rephotographed at higher resolution and under different lighting. Observations by the Mars Global Surveyor in the late 1990s and then by the Mars Reconnaissance Orbiter in the 2000s filled in the mesa's detail. The new images, crisp and granular, showed a natural landform of ridges and terraces, a complex interplay of rock strata and shadow that, when viewed at scale, lost the anthropomorphic gestalt. The eyes collapsed into alcoves, the mouth became a shorter alcove and slump feature. The face that had once seemed so specific was revealed to be an accident of angle and scale. For many, that verdict was unsatisfying. The public had invested an image with mythic weight, and the correction felt like deflation. But the scientific correction offered its own kind of wonder, the revelation that the planet's surface could produce forms which, under particular conditions of light and resolution, could read like a face, was itself an insight into the power of physical processes and perceptual habits. It underscored a central idea from the ongoing inquiry into Mars, that the planet's geology is a language written in slow processes, sometimes mimicking the grammar of intention without any mind behind it. What the face also revealed was how meaning migrates from image to ideology. The formation became an icon in popular culture, on book covers, in television shows, in debates about the possibility of extraterrestrial life. It was a rallying point for those who saw an institutional reluctance to contemplate large hypotheses, and for those who mistrusted scientific gatekeeping. For many scientists, the episode was instructive in a different register, the need for better science communication. The image taught a discipline in public explanation and context setting. It taught that data once released will be reframed and repurposed by the collective imagination, and that scientists must anticipate and address that repurposing. Marin, watching the slow retelling of the face across media cycles, felt both exasperation and sympathy. Exasperation because sloppy interpretation eroded public faith in rigorous inquiry. Sympathy because the human yearning to see continuity in a vast cosmos was understandable, even noble. In quiet moments, Marin would recall older debates, Schiaparelli's canali and Lowell's canals, and see the pattern repeat. Limited data begets maximal story. The work, then, was not to deprive the public of wonder, but to channel it toward patient curiosity. There was also a deeper, quieter lesson in deep time. The face episode highlighted the fragile persistence of surface memory. If a simple mesa could captivate a planet in the public mind, it was because humans projected hopes of continuity, of a cosmic chain where memory could be sustained beyond species-level extinction. The possibility that an intelligence could leave a durable monument resonated with earthly anxieties about legacy and erasure. Conversely, the revelation that the face was likely a natural feature emphasized how easily meaning can be made and unmade. Geological processes. Wind, ice, impact, freeze, thaw, carve, and erase in rhythms much longer than human lifetimes. The palimpsest of planetary surfaces complicates any easy search for intentionality. Beyond the philosophical, the face had practical consequences. It pushed space agencies and funders to think about the optics of disclosure. About the responsibility of tempering dramatic potential was method. It also nudged engineers and mission planners toward higher resolution reconnaissance as a priority for ambiguous regions. If a single image could restructure public imagination, then follow-up imaging and atmospheric modeling became not only scientific necessities, but obligations to an engaged public. Even after higher resolution images dispelled the anthropomorphic temptation for many, the face persisted in collective memory as something more than a mistaken perception. It became a symbol for the encounter between desire and method, between myth and measurement. For some, it remained a conspiracy emblem, for others, a cautionary tale. For Marin and colleagues, it became another node in the long dialogue about how humans look at other worlds and at their own pasts. In the end, what mattered was not whether a face had once been carved into Martian stone, but what the episode taught about looking. The formation at Cydonia forced a re-examination of the tools of sight, both optical and cognitive. It taught that instruments expand what can be known, but that interpretation is always a human activity conducted with feet of clay. It reminded observers that images do not speak alone, they speak through the minds and cultures that receive them. The lesson returned to the earlier themes of deep time and fragile memory. Marks can be durable, but their meanings are not fixed. They are the work of perception as much as of history. If the face on Mars did anything enduringly useful, it was to remind humanity that the search for traces, whether on another planet or buried in Earth's strata, must be patient, iterative, and humble. The image pressed an ethic to test extraordinary appearances with extraordinary care, to resist the ease of storytelling when the data demand caution, and to honor wonder as a motive but not a conclusion. The face, whether an illusion or an artifact, became a prompt for a better way of looking, one that holds open the possibility of discovery without collapsing into legend. Years later, in rooms lit by modern displays and fed by data streams that dwarfed the bandwidth of the Viking era, Marin sometimes returned to the old images. They were, in their way, reminders of a human habit, the need to narrate a universe that is often indifferent. Studying the high-resolution maps, Marin felt again the smallness of human time against geological patience and the warmth of the opposite feeling. That curiosity, however fallible, is what animates inquiry. The face had been both a misreading and a teaching. In that duality lay its strange value. Thus, the photograph that once suggested a gaze from afar came to be understood not as proof of kin, but as a mirror for humanity's own modes of recognition. It was a lesson carved into the institutional memory of planetary science. Images will seduce, the public will narrate, instruments will correct, and through the push and pull of those forces, knowledge will slowly accrue. The face did not close the question of life or intelligence elsewhere. It opened another, quieter, and perhaps harder to sustain: how to look at signs of the past without mistaking the architecture of the mind for the architecture of the world. What does it mean, in a long ledger of planetary time, to find something that looks like a purposefully placed stone? What does a pyramid-shaped shadow do to the human imagination when it falls across an alien plane? These are not idle questions. They settle like dust over instruments and into the grooves of meetings, where careful people try to convert astonishment into method. The Cydonia region of Mars supplied exactly this kind of provocation. Not only a face that could be read as a visage, but a cluster of stepped, angular forms that some eyes translated immediately into pyramids. The shapes in question were at once mundane and uncanny. From orbital strips and mosaics they read as raised platforms, truncated mesas with planar faces, sharp ridgelines that met at edges, seeming corners that stood out against the sweep of the plane. At the resolution of the first imagery they had a clarity that invited narrative, the sane cognitive click that makes an observer read faces and cloud shadows, or see towers in the profile of a coastline. For the public, a single word sufficed: pyramid. It carried a cargo of meaning. Pyramids had a long history on Earth as monuments of intent and time, durable, geometrically precise, culturally legible. To see their echo on Mars suggested continuity with a human way of memorializing, if not an identical history, then at least a familiar grammar of monumentality. Scientists had a different starting point. They asked not what the shapes meant to a poet or to a tabloid, but how the shapes could arise from physical processes that do not consult intention. The language of geology offered several plausible authors: joint-controlled erosion, differential weathering of sedimentary layers, basaltic cooling fractures that produce blocky relief, and aeolian sculpting that accentuates angularity. On Mars, with its thin atmosphere and persistent winds, erosion works differently than on Earth. Fine dust moves as a slow river, abrading exposed faces until a bluff becomes a sharp-edged plate. Freeze-thaw cycles are rare, but thermal stresses can fracture rock along pre-existing weaknesses, producing rectilinear patterns. Salt and chemical weathering under past watery regimes can produce bedding planes that peel into near-planar slabs. To convert a formation into a pyramid requires, in many cases, not so much sculpting as selective removal. Softer material vanishes and the hard, joint-bounded blocks remain. Yet data complicates parsimony in remarkable ways. Different instruments attend to different aspects of a formation. Each instrument tells a truth that is partial. A visible light image picks out albedo contrasts and shadow geometry. A stereo pair gives height and slope. Radar penetrates dust and hints at internal layering. Thermal inertia reveals how quickly a mass warms and cools, indicating grain size or induration. When several modalities reinforce the same reading, sharp corners, consistent planar faces, internal echoes suggesting voids or stratified fill, the anomaly becomes harder to dismiss as mere coincidence. The Cydonia pyramids thus sat at the meeting of multiple stories, one of human pattern-seeking and another of real physical processes that occasionally make the world look as if it were composed by a mind. In a mission operations room, the effect was not immediate spectacle, but a sequence of small, exacting acts. Images arrived as packets of numbers, then as images on a screen, then as contrast, stretched prints on glossy paper. Analysts adjusted histograms, examined sun angles, and overlaid topography. One person, often Marin in the narrative that had been following the region from earlier hints of the face, would point out a corner that seemed to persist across passes. Another would note a slope that changed character with sun elevation. Check the slope azimuth, someone would say. If the ridge persists at different lighting, it's not a shadow trick. The language was procedural. The affect beneath it was a mixture of curiosity and caution. They did not leap to headlines, they organized follow-up. Follow-up meant both more imaging and careful analog work. On Earth, geomorphologists visited analog terrains, badlands cut into layered sedimentary rocks, basaltic lava fields with columnar features, deserts where wind had carved yardangs, and isolated buttes. They took measurements of corner angles, of the spacing between joints, of the way bedding planes delaminated. Back in the lab, teams ran erosion models. If a block of rock has orthogonal joint sets and differential cementation between layers, what shape will remain after 5 million simulated years of wind abrasion? How sharply can an edge be preserved under Martian pressures? Those exercises often yielded forms that were close cousins of the pyramidal silhouettes in Sidonia. A straight joint set, intersected by a bedding plane, could produce a stepped mesa with apparent corners. Pyramids, if seen at a distance and under oblique light. Still, nuances mattered. On occasion, disparate forms aligned in an improbable geometry, multiple truncated mesas arranged with roughly similar taper and orientation, or corners that, when mapped, suggested a grid-like spacing, unlike expected random jointing. In such distributions, the argument shifted. Could geological processes, operating under planetary stress fields and sedimentary templates, produce repeated motifs across a plane? Yes, regional tectonic regimes and uniform layering could bias orientation. Yet if the repetition exceeded statistical expectation, the curiosity deepened. Statistical tests were brought in. Teams asked, what is the likelihood that n mesas on this plane would present the same apparent corner within a tolerance of x degrees by chance? The answer rarely produced certainty. It suggested probability bands and uncertainty sufficient to attract attention, but rarely to overturn the default of natural process. The cultural life of pyramids on Mars took off on 2 registers. There was the straightforward chain, image, press, public, imagination. Photographs of the Sidonia features circulated in newspapers and television programs. They were embellished, cropped, and captioned. For audiences already primed by the face on Mars, a pyramid invoked an architecture that made narrative economy easy. The second register was subtler, a symbolic association with Earth's ancient builders. Human memory loves parallels. The sight of a truncated, triangular hill on Mars redirected imaginations toward places like Giza and Teotihuacan, toward cultures that turned geometry into permanence. That association did cultural work. It rendered a remote rock into a sign, a possible answer to the existential question of whether intelligence is a fluke or a recurring pattern in the cosmos. For scientists, however, that symbolic work was precisely the danger. It risked making anomalies into confirmation bias. It risked funneling funding into sensational investigations that might yield little more than high-resolution images. Marin and colleagues therefore had to balance 2 responsibilities. They needed to satisfy public interest. After all, tax dollars and democratic oversight shaped mission priorities, and they needed to steward a rigorous methodology. The compromise was often the method of staged revelation: obtain better stereo, sweep with radar, model internal structures, and publish results with explicit caveats. Scientists became, in this sense, translators between awe and arithmetic. Dialogue, small, procedural exchanges captured the tenor of this translation. In one recorded meeting, the imaging specialist, voice flattened by the strain of hours, said, "If we can secure another pass at a different sun angle, we can constrain whether that corner is topographic or photometric." A colleague answered, "Schedule the radar sweep too. If there's an internal layer that aligns, that will help." The words were plain. The stakes, to the team, were existentially moderate. Get clearer data. The human heartbeat behind the phrases was the same as before. Curiosity pressed against method. The desire to see continuity overlaid with the discipline of doubt. Materially, the pyramids also forced engineers to face difficult trade-offs. High-resolution imaging consumes bandwidth. Radar sweeps require power and time. Spacecraft planners had to prioritize. Sidonia might be uniquely interesting, but the planet had many mysteries. Should a mission divert from prime scientific targets to re-image a contentious plane? These were risk-benefit calculations that involved not just science but politics and public relations. The existence of shape-laden images in the cultural ether meant decision-makers felt pressure. That pressure in turn shaped the allocation of scarce resources. It was a reminder that the act of looking is never merely scientific, it is social. Beyond terrestrial politics lay deeper, more reflective questions about the durability of messages. On Earth, human monuments endure when they are carved from particular materials and maintained by successive caretakers. The pyramids of Egypt last because blocks were quarried and set with intention, and because later cultures, for various reasons, did not dismantle them entirely. On Mars, the pyramids were rock types shaped by environment. The critical thought here was comparative preservation bias. Geology can sometimes favor the persistence of certain shapes. If a particular rock type or layering is especially resistant to abrasion, that feature will survive while surrounding material erodes away, producing what looks like architecture. Thus, the long-term survivability of a shape does not necessarily indicate intention. It may simply reflect material luck. On the philosophical axis, the debate about the pyramids revealed a familiar, haunting question of deep time. If an intelligence had existed and left durable marks, how likely is it that those marks would be recognized tens of millions of years later? The human answer tends to oscillate between optimism and despair. Optimism imagines carefully engineered messages, monuments designed to survive erosion and be legible across eons. Despair reminds that even the most massive human constructions have a geological vulnerability. Cities sink into marshes, records dissolve into anthracite, marble succumbs to acid rain. The Cydonia case was instructive because it foregrounded that tension. A durable geometry on a planet does not automatically equate to a message. It may equally be a happenstance survivor of differential erosion. Speculative narratives filled the vacuum when data could not decide. Writers and commentators spun scenarios: an ancient Martian society that built pyramids as burial monuments, an external intelligence that used simple geometric markers as waypoints, a natural planetary process that accidentally wrote a script in stone that looked deliberate to another species. Each scenario illuminated different anxieties and hopes. Together they created a cultural pressure cooker in which the public appetite for wonder sometimes outpaced the instruments available to answer it. As more sophisticated missions mapped Cydonia with finer granularity, the scientific consensus moved toward an explanation grounded in geology, but without the triumphal coldness some expected. The new images revealed stratified bedding, joint patterns, and erosional faces consistent with the way terrestrial mesas behave. Radar returned internal echoes suggestive of layered deposits rather than void cavities. Spectrometry indicated minerals, congruent with basaltic and sedimentary processes. The apparent corners were revealed to be the intersections of planes defined by jointing and differential erosion. Remarkable, perhaps in their crispness, but not beyond the reach of natural processes. For many observers, this rendered the pyramid hypothesis unnecessary. But for others, the interpretive closure felt like a loss, a cultural deflation akin to the later debunking of the face. Yet the value of the episode lay not in the demise of a hypothesis, but in what the investigation refined: a protocol for humility. Scientists learned to anticipate the human tendency to seek pattern, to communicate uncertainties more clearly, and to design follow-up observations that addressed the most seductive confusions. The pyramids episode catalyzed improvements in communication, clearer explanation of resolution limits, better public-facing visualizations that allowed viewers to appreciate scale and lighting variations, and more transparent release of raw data so independent analysts could reprocess images. There was an ironic, quieter outcome as well. The debate encouraged a deeper appreciation for how the planet itself speaks. Mars, through its winds and rock, writes in a slow hand. A mesa that reads like a pyramid at one resolution is an archive at another, layered records of ancient climates, of volcanic events, of sedimentary cycles. Even if not authored by intelligence, these formations are messages of a different kind, testimony to processes that shaped habitability. Scientists reframed the excitement. The allure was no longer merely in the thrill of finding something familiar. It was in the opportunity to read planetary history with finer instruments and more careful interpretive frames. Finally, the Cydonia pyramids remained as a cultural mirror. They reflected human desires, our yearning for continuity, for kin, for artifacts that would link us to another mind across space. They also reflected our methodological progress, how instruments and statistical tests can bend the arc of interpretation away. from narrative impulse and toward evidence. In that double reflection lay a lesson in modesty. When a planet presents a geometry that nudges the imagination, the responsible human response is neither immediate dismissal nor credulous embrace, but a layered curiosity. Measure, model, simulate, and then, with restraint, tell the story that the data most convincingly supports. The story of those pyramid-like forms did not end with a simple pronouncement. It evolved into a steady accumulation of knowledge about Martian processes and an improved public dialogue about evidence and uncertainty. Cydonia, with its face and its pyramids, continued to function as a pedagogical site, a place where the human habit of reading purpose into pattern could be taught, examined, and gently reoriented. In the long view, that reorientation is itself an achievement. It is the cultivation of an ethic of looking that honors wonder while insisting on rigor, an ethic more suited to the patient. Arithmetic of deep time than to the quick gratifications of spectacle. What is the meaning of a perfect ring seen from the stratosphere, a dark circle cut into a red plain, a belt of cliffs that runs unbroken for kilometers, or a series of concentric terraces that converge toward a silent center? The image arrives as a proposition, symmetry at a scale that strains habit, an arrangement that seems to echo the kinds of deliberate geometries humans have long associated with ritual, order, and design. The sight of such circles on a world already suspected of holding odd echoes, faces seen and then recast, pyramid-like mazes celebrated and then explained away, presses an old question anew. Are these circles the residue of natural processes or the footprints of intent? The rings, when first seen in orbital mosaics, announce themselves with a clarity that is both alluring and unsettling. From orbit they read as clean geometry, arcs that bend with near constant curvature, rims that throw coherent shadows at dawn and dusk, sometimes multiple bands nested like ripples frozen in stone. In some places clusters appear, several circles grouped together, their centers offset from one another in a rhythm that could be described as pattern or coincidence. In others the rings are solitary, lonely on the plane, their symmetry unaccompanied. The initial reaction among observers is predictably human, an immediate folding of the visual into narrative. Circles mean enclosure, ritual, astronomy, settlements. Circular forms on Earth often bear social meaning. Henge monuments, stone circles, city walls, amphitheaters. The mind projects its catalogue of meanings onto the Martian surface. But projection, however compelling, is only an opening move. The next layer of response is instrumental. Instruments translate shape into numbers. Altimetry gives profile and depth. Radar probes reveal subsurface complexity or the lack of it, multispectral and hyperspectral. Sensors attempt to name the mineral palette that composes the rims and fill. Gravity anomalies hint at denser cores. Magnetic surveys whisper of buried contrasts that do not match basaltic expectations. Each modality brings its own voice to the chorus, sometimes harmonizing, sometimes contradicting. A ring that appears as a neat raised rim in visible light may, under synthetic aperture radar, show internal stratigraphy consistent with a collapsed volcanic vent, a caldera whose rim remains because the surrounding material slumped inward. A concentric set of terraces could be the erosional remnants of an ancient lake bed where cyclic deposition produced rings of varying in duration that later differential erosion accentuated. Yet other circular formations yield signatures of salt diapirs or ring dikes, intrusive features where magma exploited a circular weakness in the crust. Still others echo the geometry of impact, a central uplift, secondary rings, and ejecta patterns familiar from craters seen across planetary surfaces. The question of clusters complicates the reading. Natural processes can produce clustering under certain conditions. A region of crustal weakness might develop a swarm of volcanic vents. Stress fields might produce parallel fracturing that favors. Circular collapse over wide areas, repeated impacts from a fragmented projectile can seed a chain of craters. To decide whether clustering is unusual requires statistics, the calculation of expected distributions against null models that take into account regional geology and planetary history. And yet statistics are blunt tools when time is deep and processes are many. Rare events exist. Finding a cluster that deviates from expected randomness is noteworthy, but not proof of design. There is, however, a different class of circular forms worthy of special attention, those that show symmetry at multiple scales and the repetition of proportions that suggest a template. On Earth, human-made rings, from stone circles to roundhouse settlements to agricultural enclosures, often display repeated modularity regular spacing of elements, and a skillful use of local materials to create symbolic geometry. If Martian circles show similar regularity, recurring ratios between external diameter and internal terrace widths, repeated placements of angular outcrops at cardinal points, or construction materials with spectral signatures inconsistent with unprocessed basalt, then the anomaly moves out of morphology and into the realm of material culture. That shift is critical. Shape by itself is ambiguous. Composition and context begin to cut through ambiguity. Deep time is the great interrogator here. Structures made by intelligence are fragile against geological appetite. The difference between 1,000 years and 1,000,000 has everything to do with what survives. Human monuments on Earth, even those fashioned for permanence, succumb to weathering, burial, and the reworking appetite of later humans. A city grid can be effaced by sediment in a short geological breath. The palimpsest of planetary surfaces is not merely a metaphor, it is a material fact. On Mars, the surface has been reworked by impacts, volcanic resurfacing, and eons of aeolian transport. A ring intended to be a monument might persist if it were carved into resistant lithologies, buried and then exhumed, or built upon a scale that outstrips normal erosion. Conversely, natural processes can, by coincidence, favor the persistence of shapes that suggest intentionality. The scholar of preservation must therefore ask, what conditions would allow a manufactured circle to survive for tens or hundreds of millions of years, and how do those conditions differ from those that produce similar geometries by accident? Taphonomy, the study of decay and preservation, becomes central. If a ring is an artificial relic, it would likely show certain telltale signs: compositional anomalies, metals, glass, synthetic polymers, processed ceramics, architecture inconsistent with known geological strata, regular internal voids, orthogonal foundations, or localized thermal properties that betray subsurface construction. Instruments can test for these signatures, but each test has limits. Spectrometers are tuned to broad mineral families and may miss low concentration anomalies. Radar loses fidelity at certain depths, or in particular regolith types. Gravity data may be ambiguous in regions of complex crustal structure. Only in situ investigation, a probe, a lander, eventually a rover with sampling capability, can resolve material culture from mere pattern. And even then, contamination, sampling bias, and destructive sampling risk complicate matters. The ethical dimension creeps in like dusk. The possibility of encountering an engineered deposit raises questions of stewardship and interference. If a ring is ancient and perhaps sacred to a hypothetically vanished mind, is there an obligation to preserve it untouched? If it is a site where biological remnants might persist, sterilization protocols and planetary protection policies become moral imperatives. The act of investigating alters the site. The very instruments deployed to decipher a circle can corrode or contaminate it. Thus, the discourse around rings is never purely epistemic. It includes a deliberation about responsibility in the presence of potential otherness. Public imagination reacts quickly to such deliberations. Rings make for arresting images. They are legible on billboards and in thumbnails. Human culture rapidly grafts meaning onto form. A ring conjures ritual, astronomy, assembly. Narratives sprout: a planetary calendar etched into stone, a landing beacon left by a passing intelligence, a civic center whose stones remember speech. These narratives are not merely fanciful. They are the mental ways humans try to knit continuity across absence. They are also the very thing that scientific method must guard against, because desire for story can become a vector of error. History provides instructive analogues. On Earth, circles have collected meaning for millennia. Some, like Stonehenge, speak to engineering and ritual. Others are byproducts of industry or natural cycles. The human temptation to read intent into regularity is ancient. Rings of standing stones and embanked henges, once mistaken for natural hillocks, terraces that were later recognized as agricultural labor. The pattern repeats across planetary studies. The canal myth, the face, the pyramidal mazes. Each episode shows how limited resolution and the hunger for narrative conspire to make meaning out of ambiguity. The lesson is both cautionary and pedagogical. Training in the interpretation of form must be coupled to an awareness of cognitive biases. Scientific practice responds with layered protocols. The initial sighting of a ring triggers checks, reimage at different sun angles, collect stereo pairs to reconstruct topography, run radar sweeps for subsurface structure, acquire thermal inertia maps, and perform multispectral analysis. Analysts apply statistical pattern recognition, from Fourier transforms to fractal dimension assessment, to compare observed symmetries against null models of crustal features. Earth analog studies are summoned: coastal ringed reefs, volcanic calderas, cryptovolcanic structures, ring dikes, pingos, and human-built embanked sites. Laboratory work simulates erosional processes under Martian pressure and wind regimes to test the plausibility of naturally generated rings. Each test peels away layers of equivocation. Each negative result tightens the suspicion that a ring is natural, while positive anomalies push attention toward the extraordinary. Yet the extraordinary demands extraordinary convergence. A single anomalous ring with an odd spectral signature would be interesting. Multiple rings with repeating geometry, internal regularity, and material outliers would become compelling. Even then, the standard of proof in planetary archaeology, for that is what a claim of manufactured rings would entail, must be high. The scientific culture has learned, painfully, to prefer slower accumulation of evidence over quick, sensational proclamations. The cost of a false positive is not merely reputational, it distorts research priorities, misallocates funding, and inflames public discourse. If, hypothetically, evidence did converge on an intelligent origin, the implications would be vast. It would reframe not only planetary history but human self-understanding. The discovery of engineered rings would be a direct line into questions of lifeways, technology, cultural cognition, and demise. Deep time complicates those questions. Did an intelligence arise and vanish in geologic memory? Did it engineer durable monuments? Or did their traces persist because of compositional luck? The interpretive project would require archaeologists, material scientists, planetary geologists, and philosophers, a collective attempt to read fragmentary testimony. The project would also require a public conversation about meaning and stewardship that rises above sensationalism. Until the data move decisively, there is a quieter, necessary practice, the cultivation of humility. The appearance of rings is an invitation to measure, test, and wait, not to leap. It is an occasion to refine methods that can separate sweet illusions from stubborn anomalies. The presence of clusters of circles demands better statistics and better sampling. It demands an ethic of disclosure that explains not just findings but limits, uncertainties, and the range of plausible explanations. It demands a patience attuned to deep time, an acknowledgement that some questions cannot be closed in a single mission, that layers of evidence may accrete only across decades of observation. In public life, rings provide a mirror, reflecting the human appetite to find company in a vast, indifferent cosmos. They rekindle hopes and apprehensions, the hope of continuity, the apprehension of loneliness. The spectacle of symmetry activates both myth and method. It is, in the end, an opportunity to teach how to look, to model how to hold wonder and skepticism in healthy tension. The measured response does not extinguish the romance of circles, rather, it channels it into a sustained curiosity capable of enduring the long patience that deep time demands. Orbital photographs keep arriving. Each pass is a chance to see the plane anew, to test whether the ring survives shifts in light and perspective, whether radar reveals secrets beneath dusty veneers, whether spectra whisper of something more than basalt and altered regolith. The rings, mute and patient, wait within their geometry. The human response, from the gasp of the first glance to the careful diffusion of doubt into disciplined inquiry, is part of the story. In that slow exchange between surface and sight, between pattern and method, the planet speaks and humans learn to listen. Whether the circles are the accidental architectures of physics or the fossils of intelligence, they are testimonies to the unpredictability of geological processes, to the fragility of memory across eons, and to the enduring need for a practice of observation that is at once exacting and humble. What, precisely, counts as a signature? Is symmetry itself an argument, a handwriting left by a mind so distant in time that its breath has long since stopped? That was the image that opened the next chapter, not a face or a single mesa, but a suite of shapes so regular that they read like punctuation on a blank page, rings and straight lines, perfect circles intersected by orthogonal furrows, arcs so smoothly curved they seemed to have been traced with an unseen compass. The orbital survey called them anomalies at first, then insisted on the word that would stick: markings. Juvu, the team began to mutter in private, the countersign, the signature left in answer to time. The data arrived in the late hours when the control center had thinned to a small, bleary crew and the monitors pulsed with the slow certainty of downlinks. A new orbiter, equipped with a multi-band interferometric imager and a synthetic aperture radar tuned for fine subsurface resolution, had swept the plane repeatedly, and an algorithm designed to hunt for curvature and linearity had flagged a cluster of features. At first glance, the images were almost cruelly simple. 3 concentric rings, each rim continuous to within a fraction of a degree, bisected by a long, nearly straight groove that ran for dozens of kilometers and met a second groove at a right angle. The intersections were clean, the radii precise, the shadows consistent under differing sun angles. Whatever irony the desert wind had left, the shapes refused to blur. Marin watched the first composite printout like a person who has been told a joke and does not yet know whether to laugh. The face had taught patience, the pyramids had taught the same. Now the data presented an escalation, patterns that resisted the most immediate geological explanations. Marin felt a familiar vertigo, not only excitement, but a deepened sense of ethical weight. This was not gossip anymore, the instruments were converging. "Run a Huff transform on the rim," said a voice from the processing bay. The language of mathematics filled the room, lines in parameter space that promised to quantify what the eye insisted was true. Someone else cued the radar tomography, then overlaid thermal inertia maps and multispectral indices. The room moved with a choreography that would have looked ordinary to an observer who did not know the stakes. Scripts executed, histograms stretched, algorithmic thresholds adjusted. To the people in the room it was urgent as a prayer. The first results were not definitive, but they were unsettling. The Huff transform returned strong, localized peaks at radii that matched the visible rims to within a meter. Radar echoes showed layered structure within the rims that suggested either an unusual sequence of deposition or a constructed fill. Thermal inertia varied radially in a way not typical of simple sedimentary rings. Multispectral signatures hinted at compositional heterogeneity within the rims, a pattern repeated in the groove intersections. Across modalities, the same geometric coherence persisted. "Natural ring dikes can be circular," a senior geophysicist said, voice steady, "but they rarely present with this kind of multiscalar regularity and these material contrasts. The radial uniformity is uncanny." The word uncanny traveled like a small cold through the room. It was science speak for something that did not fit the model comfortably. The team did what teams have been trained to do since the early canal debates. They sought analogs. Fieldwork was organized in miniature. Geomorphologists turned their attention to terrestrial ring structures, volcanic calderas, circular fault basins, salt domes, impact craters with unusual central peaks. Wind tunnel experiments were planned. Numerical erosion models were parameterized to Martian atmospheric densities and particle fluxes. Samples were compared to spectra from known basaltic and sedimentary provinces. Each analog chipped at the hypothesis, sometimes making the geometric case look more plausible as a natural outcome, sometimes failing outright to replicate the observed regularity. The failures were as telling as the successes. In a wind tunnel run designed to test selective abrasion on a layered block, researchers found that while wind could accentuate linear ridges and isolate resistant layers into raised arcs, producing 3 nearly concentric rings with such precision was highly unlikely unless the subsurface layering itself had an unusual composition, a repeating sequence of hard, soft, hard strata with consistent thickness. That could happen, they noted, in a depositional environment dominated by rhythmic climatic cycles, a planetary scale, metronome of sedimentation, but such cycles would leave broader traces across the plane. They would not, on their own, explain the orthogonal grooves cutting the rings like a pair of rulers. Statisticians were brought into the conversation. They turned the plane into probability space. What was the likelihood of finding 3 coaxial rings of the measured radii within a given area by chance? Given the known distribution of crater sizes and erosional remnants, what was the expected frequency of long straight grooves that maintained their azimuth to within fractions of a degree over tens of kilometers? The numbers leaned toward improbability. It was not proof. Statistics are never proof, only weight, but it was weight enough to elevate the region from curiosity to candidate for prioritized observation. Every instrument that agreed increased the temptation to name the marks. Every instrument that disagreed underscored the need for caution. The team had hard lessons to remember. The face had shown how low-resolution images could seduce a public. The pyramids had shown how human pattern-seeking could conspire with poetic analogy. Now the shapes were broader, sturdier in the data, and the decision before them was not merely technical but moral. How to proceed in the presence of something that might be the relic of an intelligence, or might be an extraordinarily rare ambush of natural processes. Marin felt that moral weight in sleepless nights. There were practicalities to manage, arranging a sun-angle campaign, lobbying for an additional radar pass, rerouting a scheduled imaging slot. But there were also private reckonings. What would it mean if a ring or a line were an intentional mark, a signature meant to last. How would humanity prepare to read a message written in a language not our own and perhaps not even designed to be interpreted by another species? The speculative archaeologists among the colleagues spoke in hypotheticals that were meticulous and haunted. They proposed checklists. Look for regularity in proportions, test for prime number sequences encoded in the spacing of elements, search for anomalies in isotopic ratios that would betray processing or metallurgy. They were careful to label these as protocols for inquiry, not as scripts for confirmation. Publicly, the team drafted its language with care. A press release could not simply announce a signature without opening a floodgate of wishful thinking and conspiracy. Still, the control center was not an ivory tower. News outlets had ways of smelling pattern. Social feeds amplified photogenic geometry into myth. The tentative internal memo that described the features as remarkably regular was leaked within days. Headlines multiplied. Martian crop circles, ancient Martian calendar, proof of builders. The control center became a theater where the technical work and the social consequences played out concurrently. Within the walls of the lab, concrete steps were taken. A decision was made to obtain repeated observations across diurnal and seasonal cycles. Variation with sun angle would test whether the rims were sculpted by topography or only suggested by shadows. Radar tomography at varying frequencies would probe for solid foundations or hollow cores. A proposal was drafted for a targeted lander, not a full excavation but a lightweight probe to touch and taste, to measure grain size directly, to perform in situ geochemistry on a rim sample. The planetary protection team weighed in. Sterilization protocols were tightened. The possibility, however remote, of contaminating a site that might carry biological remnants was taken seriously. The rhetoric of discovery met the rigor of preservation. The team also rehearsed how it would handle outcomes. What? Ethicists were consulted about stewardship. If the marks were signs of an extinct intelligence, would humans have the right to disturb them? If they were messages, should they be preserved unaltered until a broader multinational council could decide on handling? The scenarios sounded like the scripts of science fiction, but they were practical planning. Who owns a ring on Mars? What legal and moral frameworks were in place for an interplanetary archaeological site? The questions had no easy answers, but asking them early kept the discourse from being improvised in a moment of media frenzy. At the level of method, the team refined its metrics. Instead of relying on a single measure of regularity, they developed a composite index that combined geometric precision, cross-modal consistency, material heterogeneity, and statistical rarity. Each component carried a weight calibrated by analog studies and simulations. The composite index did not produce certainty. It produced a triage, candidates that merited lander study, those that warranted further orbital observation, and those that could be reasonably explained by known processes. Across the public sphere, narratives multiplied. For some, the rings were a Rosetta Stone waiting to be deciphered. For others, they were a lesson in cognitive humility. Anthropologists cautioned against projecting human symbolism onto alien landscapes. Cultural commentators warned that the search for continuity in the cosmos often mirrors anxieties about extinction and legacy. That conversation, scientific, ethical, cultural, was itself part of the discovery. The planet, inert and patient, had become a mirror for human meanings. Marin watched these conversations with a careful bluntness. The team had tools and models. They also had fallibility. The new shapes were more compelling than previous anomalies had been, but compelling was not the same as conclusive. The safest path forward combined openness with procedural discipline, collect more data, test more models, involve more disciplines. Marin often found that the tension between haste and caution created the clearest ethical light. To move too fast risked error and contamination. To move too slow risked missing a narrow window of orbital geometry or seasonal exposure. The orbit of instruments is unforgiving. Timing in space is a luxury not always afforded. At night, when the monitors dimmed and only the hum of cooling fans broke the silence, Marin would take the printed composites and trace the arcs with a finger. The motion was almost childish, an attempt to feel the curvature, to sense whether the arcs suggested intent. But the hand could not tell a geological history from a signature. It could only mark the place where curiosity met method. There was a deeper, speculative strand to the conversation that the team could not ignore. If a mind had ever intended a message to be read across deep time, what strategies might it use? In theory, certain designs are more robust than others. Geometry resists decay where material solidity concurs. Repetition across scales can survive differential erosion. Simple. Mathematical relationships, circles, ratios, prime-numbered arrays can be recognized by a diversity of minds. Some suggested that a ring bisected by orthogonal lines would be a deliberately low information, high survivability script, easy to make, hard to erase, and legible across many sensory modalities. The idea was elegant and resonant, but also entirely speculative. It had to be tested against the sober arithmetic of sediment, lava, ice, and impact. The moment of greatest suspense arrived with the first scheduled radar sweep at higher frequency and a sun-angle campaign that would image the plane under dawn light. The team gathered as data streamed in. Histograms shifted, radargrams unfurled like subterranean tapestries. For a long minute, nothing resolved. Then a pattern emerged in the radar, a concentration of layering within the rim that followed the curvature with a fidelity beyond what simple deposition models had predicted. Thermal inertia reinforced the picture. The rims warmed and cooled differently from the surrounding plane, hinting at altered cementation or composite of materials. The groove appeared to have a substructure, a buried channel filled with a different signature. The room exhaled as one organism, not triumph but attention sharpened. The instruments had not declared intent. They had pushed the question back onto the team with greater force. The maths were real in a way that deserved serious in situ work. Funding conversations began in earnest. The team wrote proposals with the vigor of people who knew that time, money, and orbital mechanics would not be patient forever. The public conversation continued to swill with speculation and awe. Marin and colleagues insisted on one line of communication. The data had grown suggestive, not conclusive. There was a case to build for a mission that would touch the rim and sample the groove, not to prove a myth, but to read a planetary archive with the tools of archaeology and geochemistry to find out whether the geometry was the handwriting of processes or of a mind long gone. The larger lesson crystallized slowly in the team's after-action notes. Notes! The countersign was not merely a hypothesized artifact, it was a test for how humanity looks. The shapes forced a reckoning with scale. The measure of a thing is not only its size, but the time over which it persists. The possibility of a signature in stone asked people to think not as journalists or pundits do in the brevity of headlines, but as stewards of a longer inquiry. It asked for patience, for interdisciplinary humility, for a public fostered in the nuance of uncertainty. If the rings and lines were a message, they would speak to a different tempo than human headlines allow. If they were the product of rare but natural processes, they still mattered, because they told a chapter of planetary history and hinted at conditions that had once existed. Either conclusion would be an enlargement of knowledge. Either conclusion would change the way people framed survival, memory, and the fragility of inscription across epochs. In the end, the discovery was less a plot twist than a summons. It called for methods that could answer with care, for institutions robust enough to resist the lures of instant spectacle, and for a public conversation rich enough to hold wonder without surrendering discernment. The rings waited, silent and patient, their curvatures indifferent to the passing of human seasons. The marks on a red plane had become a shared problem, a specimen to be read, a boundary between story and evidence, a prompt to measure what could be measured and to live with the questions that time refuses to resolve quickly. Marin pressed a final soft order to the team: pursue the follow-ups, shield the site from premature interference, and prepare the public for a long, careful inquiry. The words were procedural, but they carried an ethic. Look with humility, speak with restraint, and never let the appetite for certainty drown out the discipline of doubt. The planet, in its patient geometry, had posed a question. Die, you witch! Had shifted from a whispered phrase into a project, a long-term work in which the most consequential discoveries would be earned gradually, through the slow accumulation of data and the steady sharpening of human attention. What, exactly, does a long straight line mean when it is measured in hundreds of kilometers and set against the red silence of a planet? Is it an old river, a scar left by water that flowed when the climate was different? Or is it the trace of a plan? The scar of a channel cut with purpose, engineered to move something essential across distance? That question arrived like a cold question of scale, small enough to be represented in a map, large enough to rearrange histories. The new strips of imagery made the question unavoidable. From orbit, features that had once read as a maze of wind-etched furrows now resolved into ribbons, continuous troughs cutting across planes, sometimes braided into parallel lanes, sometimes meeting in junctions that suggested design more than accident. Some of the longest stretched for hundreds of kilometers, their course surprisingly rectilinear for such distance. Where the earlier inquiries had been satisfied with faces and pyramids, these grooves presented a challenge of narrative and method. They raised an even more intimate worry: what it would mean if those furrows were not merely features, but records of labor, of water managed and moved by minds long vanished. In the analysis suites, the response was practiced and human. Screens glowed, layers multiplied. One monitor showed stereo-derived topography, another displayed radargrams, a third ran a spectral composite tuned to detect hydrated minerals. The team's work followed a ritual of comparison: measure the sinuosity, compute the planform fractal dimension, extract the bifurcation ratio. Each metric was a cautious dialect, an attempt to translate shape into story without importing human hunger for continuity. Yet the hunger was present. It threaded through conversations, quiet and bright, the same curiosity that had made 19th century observers see canals and Schiaparelli's canali, and that had later read a face into a mesa. If it's fluvial, someone said, fingers on a trackpad, we should see meander wavelengths at this scale. The voice belonged to an imaging scientist who had learned to couch excitement inside lists of observable consequences. Natural river systems have characteristic relationships between channel width, wavelength, and slope. If these features preserve a low sinuosity over hundreds of kilometers, then either the gradient was extremely high once, which suggests catastrophic outflow, or the alignment was constrained by structural controls, or by design, another voice offered, softer. It was the conversational equivalent of a hand laid across a hot stove, a temptation acknowledged and quickly withdrawn. The group had learned to name their temptations in the open air. Naming was a way of keeping them honest. Analyses were run in quick succession. Sinuosity indices compared the lines to terrestrial analogues: braided rivers, inverted channels preserved by differential erosion, and ancient aqueducts cut through bedrock. The planform geometry was measured against expected randomness. A natural river develops sinuosity as it erodes and deposits. It bifurcates according to sediment load and slope. It follows energy-minimizing paths. Engineered canals, by contrast, often show unnatural straightness over long distances, abrupt changes of direction only where gradient control demanded it, and junction geometries consistent with human-made locks and distribution networks. At first glance, the longest grooves displayed a disquieting blend. Large stretches were remarkably straight, their azimuth held to within degrees across desert expanses. At other points, they curved with a gentle, almost deliberate arc. At some junctions, multiple channels aggregated into a trunk that resembled distribution work more than confluent drainage. Thermal inertia maps suggested that some channel floors had higher induration than surrounding plains, and radar sounded beneath dust to reveal internal layering. Spectral signatures hinted at clays and sulfates concentrated along their lengths. Those mineral assemblages were the kind that form in standing or slowly flowing water, a fact that pushed the interpretation toward aqueous history and away from purely Aeolian hypothesis. Yet instruments had their own languages of ambiguity. Synthetic aperture radar could reveal a buried bed form, but it could also be misled by subsurface echoes that mimic layering. Thermal inertia varied with grain size, cementation, and lag deposits. An increased inertia might indicate coarse clast deposited by flowing water, or indurated cement derived from chemical alteration. The team's statisticians stepped in, converting pattern into probability. What was the likelihood of such straightness occurring by tectonic or volcanic constraints? Could wine carve such grooves by preferentially eroding lines of weakness? What was the statistical distribution of channel orientations across the broader province? The answers were partial. In regions where crustal faults trended in the same azimuth, linearity could be inherited from structural grain. Lava tubes collapsed to form linear depressions. Periglacial processes left polygonal troughs that sometimes aligned into chains. But the specific combinations observed, extended linearity, internal stratified fills, hydrated mineral concentrations, and complex junction geometry, did not fold neatly into any single natural catalog. They resisted comfortable closure. It was here that the older lessons, distilled from the face and the pyramids, became operational. The team resisted two errors: first, the seduction of quick myth, and second, the flattening of wonder into reflexive dismissal. Protocols were drafted: re-image at multiple sun angles and seasons, schedule radar tomography across frequencies, perform higher resolution spectral sweeps, and map the surrounding stratigraphy for depositional contexts. The idea was to pressure the grooves with orthogonal modalities until a consistent narrative emerged. In private, the discussions moved into morally freighted territory. If these were once rivers, what had driven their disappearance? If they were channels deliberately cut, who had cut them and why? A pattern that suggested waterworks implied an economy of labor, a distribution network that pointed toward settlement, agriculture. perhaps even storage infrastructure. The notion of canals reawoke human anxieties about endurance, the fragility of traces across deep time. Human irrigation networks, even those built from stone, require maintenance. Over geological spans, they vanish or become buried. The survival of a waterwork across millions of years would be an act of material luck as much as engineering ingenuity. Yet the possibility of engineered channels also posed methodological perils. Pattern detection algorithms could turn a braided paleochannel into a crisp line if thresholded incorrectly. Edge detectors, when applied with aggressive settings, skeletonize continuous geomorphology into simple linear elements. The team therefore instituted a second set of tests, explicitly aimed at algorithmic bias. Every image was reprocessed with alternate filters. Human analysts re-inspected raw data without automated overlays. The goal was to make sure that the instruments were not fabricating the signal they were hunting. Dialogue in these rooms became a practice of self-correction. "Let's not forget the inverted channel hypothesis," the geomorphologist urged one afternoon, pinching the bridge of their nose in that practiced expression of someone who had watched narratives ossify before. Rivers can become inverted when the channel floor is cemented or armored by coarse clasts. The surrounding plain erodes faster. The former channel sticks up as a ridge, and from orbit, ridges can read as lines. The imaging specialist nodded, acknowledging the probability while adding, "But inverted channels usually preserve meander scars. The straightness over such distance is still unusual." The team turned to terrestrial analogs with renewed vigor. "Oh!" They flew drones over Earth's ancient river systems and scanned outcrop faces in deserts. They walked the beds of dead rivers and measured the dimensions of aqueducts carved by humans, from Roman conduits to Incan canals. These analogs were not perfect. Terrestrial climates, gravity, and biological agents add filters that Mars lacks. But analog fieldwork taught a crucial lesson: materials and process matter. A human channel will frequently betray itself in construction marks, in discrete revetments, in regular cross-sections, in repeating junction geometries designed for distribution efficiency. A natural river, by contrast, will show a stochastic signature with variability linked to episodic floods, sediment load, and vegetation behavior. Ratcheting the inquiry further demanded in situ contact. Orbital data can diagnose geometry and composition at a distance, but it cannot feel the texture between fingers, taste the isotopic signature of salt, or read striations on a mortar surface. The team drafted proposals for a rover mission with a suite of instruments tailored to this question: a microdrill to sample channel floors, a rugged microscope to search for tool marks or regular bedding, an X-ray diffraction unit to pinpoint processed minerals, and a mass spectrometer to test for non-natural fractionations and isotopes that metallurgy or burning might produce. All of this, however, invoked the planetary protection dilemma. A lander touching a suspected cultural deposit risks contaminating evidence not only for life but for technology. Ethicists were consulted. What obligations did humanity have toward a site that might be the product of other minds? Preservation, they argued, should be the default, yet preservation itself is ambiguous. To leave a site untouched can mean losing the only opportunity to retrieve ephemeral signals that degrade with exposure. A delicate balance had to be calibrated: minimal disturbance sampling, strict sterilization of sampling tools, and an international oversight body to guide excavation strategy. Outside the scientific corridors, the grooves ignited a cultural cascade. The public response moved along familiar tracks. Online forums ignited, some voices urging immediate excavation, others suspecting institutional cover-ups. Artists rendered the channels as grand aqueducts with suspended water. Poets imagined them as dry arteries of a city whose blood had long ceased to flow. Some commentators leaned into the political. If the grooves were engineered, what did that say about the universality of organization and planning? If they were natural, could they teach humanity about catastrophic outflows and the fragility of habitability? Those conversations mattered. They affected budgets and timelines. Space agencies found themselves negotiating not only scientific priorities but public expectations. A team learned painfully that managing speculation was as important as managing instruments. Clear communication strategies were drafted, not headlines, but layered explanations that differentiated between what the data suggested, what remained ambiguous, and why further study was necessary. The goal was to cultivate an informed patience in the public, to resist the sensational bandwidth of instant certainty. Slowly, the data accumulated. A multi-angle sunsweep confirmed that certain apparent linearities persisted regardless of lighting. Radar tomography showed internal heterogeneity in some channel fills, alternating lenses of coarse and fine material, signs consistent with episodic flows. In some segments, spectrometers picked up hydrated minerals clustered along berm-like features, an indicator of aqueous deposition or alteration. In other segments, the channels cut across topography in ways inconsistent with downhill flow, suggestive instead of linear excavations or collapse along buried tunnels. The mixed signals refused a single verdict. The team organized a small transdisciplinary reading group: geomorphologists, planetary chemists, archaeologists with experience in desert preservation, statisticians, and philosophers of science. The sessions were forensic and humane. Each participant presented a plausible narrative and then enumerated the weakest links. The archaeologists asked for evidence of habits, regularity of cross-section, artifacts aligning with channel banks, residues that suggested storage. The geomorphologists asked for paleoslope reconstructions and sediment provenance studies. The chemists demanded in situ isotopic work. Statisticians cautioned against over-reliance on singular measures of straightness and recommended composite likelihood approaches. One morning, during a long meeting that extended into the thin dawn of the control room, someone asked a question that reframed the debate. If these grooves are artificial, what signals would their makers have embedded to survive deep time? The question shifted the conversation from detection to design. It opened a speculative channel that was still disciplined. The group considered the robustness of various signatures, geometry repeated at multiple scales, materials chosen for durability, mathematical relationships like simple ratios or prime number spacing, and the placement of redundant markers across a landscape to hedge against burial. If an intelligence had intended to leave a persistent message, certain design choices would plausibly recur. Those design hypotheses, in turn, suggested tests. The team developed a checklist of robust markers, multi-scale geometry, compositional outliers, repeatable ratios, and structural regularity in cross-section. The checklist did not prejudge intention. It provided a framework for triage. Sites ticking multiple boxes would be elevated for lander study. The approach was moderate and procedural, an ethic of graduated commitment. Time, however, is not patient on orbital mechanics. Observation windows closed, launch opportunities programmed years ahead. The conversation, therefore, turned to priorities. Which segments of the groove network held the highest informational yield per resource? Which parts preserved the clearest mineral signatures? Which junctions presented the most anomalous statistics? The answers were negotiated with funders, with boards, and ultimately in the calculus of what could realistically be done with constrained budgets. Even as bureaucracies deliberated, the grooves remained on the plane, indifferent, patient, mute. They bore their geometry across seasons and dust deposition, unaffected by the human arguments about them. For the scientists, that very indifference was both consolation and chastisement. The planet asked for disciplined attention, not instant conclusions. The grooves were a test of human methods as much as a test of hypotheses about past hydrology or engineering. There was a quiet philosophical outcome to this stage of inquiry. Whether the grooves proved to be paleochannels carved by rivers that flowed during more clement eras, or engineered conduits etched by hands that have vanished into time's appetite, either conclusion would be a story about preservation and loss. A natural channel would testify to a more dynamic planetary past, to episodes when water moved freely and could sustain chemistry conducive to life. An engineered channel would prove that intelligence had shaped planetary surfaces in durable ways and that memory can, with difficulty, persist. Both outcomes foregrounded the same human questions: how to read history from fragments, how to preserve what remains, and how to live with the knowledge that memory is fragile across geological spans. In the months that followed, the team refined its language and its actions. It published papers that carefully distinguished between morphology and inference. It released raw data to independent analysts, inviting scrutiny rather than control. It prepared mission concepts that honored planetary protection and designed sampling protocols to minimize contamination. And in quieter moments, the scientists themselves rehearsed the humility they hoped to model publicly. They reminded one another of earlier errors of judgment, how easily the human mind could turn a blur into an artifact, how often desire for kinship had shaped reading. The grooves taught a final lesson about signals. A line stretching across a plane can be turned by science into a signal in two ways. First, when intention underwrites its geometry, and second, when human instruments, choices, and cultures of interpretation transform pattern into message. The danger is symmetrical. One risk is to anthropomorphize the landscape, to see in the planet's skin the handwriting of a kin we long for. The other is to dismiss the possibility of intelligence too quickly, to let methodological conservatism become a reflexive denial. The ethical posture demanded by the grooves and by the earlier Cydonia anomalies is to hold both cautions together, to look without surrendering to either fantasy or dogma. When the control room emptied and the monitors dimmed, a single printout usually remained on a table, a map of a groove that arced across a province like a stitched seam. The map was a small object, paper creased from handling, annotated with measurements in marginalia. Those annotations recorded the work of a species learning to read deep time, the metrics used, the analogues consulted, the uncertainties catalogued. The groove itself continued beyond the paper, beyond the analyses, beyond the immediate reach of curiosity. It lay in the patient geography of a world that outlasted headlines and conjecture. The final move, always, was to prepare for slow inquiry. Funding proposals were drafted not as manifestos of discovery, but as commitments to careful work, repeated observation, international oversight, in situ sampling under strict planetary protection, and public transparency. The grooves demanded a long conversation among scientists, policymakers, ethicists, and the global public about what it meant to look and what it meant to touch. The question that began the episode persisted, unfixed and urgent. Were these lines the traces of water or of hands? The answer, the team agreed, would be earned gradually, measured in lines of code, pages of analysis, the patient abrasion of skepticism against evidence. The planet waited. Humanity learned to wait with it, attentive and provisional, carrying both wonder and restraint into the slow work of reading the deep past. What if a breath were heard when no breath was expected? The notion is almost metaphoric, but in the raw mechanics of planetary science it becomes literal, a localized increase in methane concentration, a plume that rises from the red plain and into the thin sky, a transient whiff recorded in the channels of instruments that do not sleep. The discovery of methane on a planet whose present surface chemistry appears stoic and oxidized is an anomaly of another order. Not a face or a pyramid, but a molecule that, by its very versatility on Earth, carries 1,000 potential stories. The reading arrived as numbers and as a kind of electric pause. An orbital spectrometer, tuned to detect trace gases in the near-infrared, registered a spike. Methane concentration, several times the local background, concentrated over a specific patch of the plane. The signal was not constant. It pulsed. It flared and faded over cycles measured in weeks, sometimes appearing in association with particular thermal regimes or with seasonal changes in solar heating. The equipment flagged it as unusual. The human response was immediate and complicated. Exhilaration threaded with the practiced caution of a field long schooled by spectacular near misses. Marin watched the first plots in a dim office where screens cast soft light across cups of long, cold coffee. Habit had taught a slow rhythm, initial excitement, immediate skepticism, reprocessing, and then triangulation. The first line of business was to test the reading against instrument artifacts. Spectrometers can be fooled by calibration drift. Solar glint can masquerade as absorption. Terrestrial contamination can travel in the folds of a data pipeline. So the team re-ran the pipeline, recalibrated reference lamps, and compared the signature with simultaneous ground-based observatories that had been trained on Mars for seasonal verification. The signal persisted. Temporal variability is interesting, a senior spectroscopist said, voice measured. It's not a steady exhalation, it's episodic. That suggests either periodic release from a reservoir or surface processes triggered by temperature or pressure cycles. The sentence was factual, but beneath it swam a more human tone, the possibility that the planet was not entirely closed and inert. Methane is an ambiguous messenger. On Earth, it is produced by life, microbes called methanogens that metabolize in oxygen, poor environments, and by a panoply of abiotic processes, serpentinization, where water reacts with olivine in ultramafic rocks producing hydrogen and then methane, thermogenic breakdown of buried organic matter during heating, and the release from clathrates and gas hydrates trapped in permafrost or under sediments. Distinguishing among these sources is the crux. It is not merely the presence of methane that captivates, it is the pattern of its isotopes, its co-associated molecules, its seasonality, and its context in geology. The instruments available could do some of that work. An orbiter's infrared spectrometer measures overall column abundance and can sometimes resolve pressure-broadening signatures that hint at altitude. Radar tomography can suggest subsurface cavities and stratigraphy where gas might accumulate. But the isotopic fingerprint, the ratio of carbon-13 to carbon-12, the presence of deuterated hydrogen, is best read close to the source by a mass spectrometer on a lander. Organic molecules of increasing complexity, simple alkanes to aromatic wings, to specific biomarkers such as hopanes or steranes, require in situ chemical separation and analysis. The team's next move was pragmatic. Schedule a targeted flyover, task a rover with atmospheric sniffing during a predicted peak, and, if possible, land a small sampling platform designed to analyze gas composition in situ. The idea of a lander sampling near a structure flagged earlier, however, raised a host of additional concerns. If the methane were tied to geological processes, the site would be scientifically rich. If the methane were tied to organics trapped or processed near the anomalous formations, the rings and grooves that had been discussed as defy, the case would be even more provocative. If, in the most speculative scenario, the molecules were associated with activity within or beneath a geometric structure, suspected of artificial origin, then the ethical and procedural stakes amplified. Ethicists and planetary protection officers were brought into routine conversations not as an afterthought, but as a requirement. Disturbing a site that might carry extant or fossil biosignatures risks contamination that could erase the very evidence sought. And if the site bore the imprint of a non-human technological process, the question of stewardship became immediate and political. Who decides how to probe an alien-made artifact? The Control Center issued a cautious directive, prioritized non-invasive observation, and design any in-situ sampling with maximum sterilization and minimal disturbance. The default posture became preservation, not exploitation. Meanwhile, the science had to proceed. The rover's tunable laser spectrometer took to the air, inhaling thin atmospheres and reporting back with a cadence that felt heroic in its steadiness. It measured not just methane, but the relative abundances of ethane, propane, and other hydrocarbons. On Earth, biogenic methane tends to be accompanied by little in the way of higher alkanes, while thermogenic methane from heated organic sediments carries heavier hydrocarbons in increasing ratios. Abiotic methane from serpentinization might be accompanied by hydrogen and certain oxide minerals. The pattern on Mars was maddeningly intermediate, methane spikes with minimal higher alkanes, sometimes co-occurring with localized water ice detections and with sulfates that suggest past aqueous chemistry. There were pockets of carbon-rich molecules detected in low abundance, some with molecular structures that begged further separation. The question of isotopic fractionation emerged as decisive. Life, by its chemistry, often prefers lighter carbon 12C over the heavier 13C, producing methane that is isotopically light. Geologic processes can also fractionate, but in different ranges. A rover's mass spectrometer returned data that hinted at lighter carbon ratios during methane spikes, though the noise margins were significant and the team urged caution. The isotopic signal is suggestive, not conclusive, a chemist said. The phrasing was deliberate. Every caveat was a tiny dam holding back premature claims. The discovery reverberated in minds trained on Earth analogs. Methane seeps on Earth offer instructive parallels. Continental margin cold seeps where microbial mats cluster around methane vents. Hydrothermal fields where chemosynthetic communities thrive. And methane hydrate destabilization events where temperature changes liberate trapped gas. In many of these environments, methane is not a solitary actor, but the center of an ecosystem built around chemical energy. If Mars had pockets of reduced compounds belching episodically, could they have once sustained, or perhaps still sustain, localized chemosynthetic communities? Comparison with Earth also sharpened the methodological checklist. On Earth, discerning biotic from abiotic methane leans heavily on context, co-location of mineralogical indicators of water-rock interaction, presence of specific biomarkers, isotopic composition across multiple elements, and microscopic structures consistent with life. The timescales were also different. On Earth, organic carbon can be preserved for billions of years under certain conditions, becoming kerogen in sedimentary basins or forming microfossils in silica-rich contexts. But the probability of preservation depends on burial, anoxia, and protection from oxidative weathering. Mars has been exposed to oxidizing conditions at the surface for eons. For organics to remain detectable, they would likely need burial in sediments, entombment within mineral matrices, or sequestration in subsurface niches. That idea, burial, and protection led the team back to the structures, shelters of rock, cavities with unusual radar signatures, or concentric terraces provided microenvironments where organics could survive the eons. Then the correlation of methane with those structures would not be random. The geometry might have aided preservation by trapping gases or by shielding from cosmic radiation. Conversely, if a structure had been engineered, it might employ materials or designs that selectively trap volatiles or concentrate organics. The distinction mattered because it reframed where the search should focus, around topographic anomalies and subsurface echoes. The public appetite for narrative predictably surged. Headlines asked the big, immediate question: life or geology? Forums filled with amateur chemists, with hopeful speculation about microbial cousins, with darker theories about hidden civilizations. The team responded as they had in earlier moments of public fever, with disciplined transparency. Data releases accompany plain language descriptions of uncertainty. The narrative reframed success, not as immediate certainty, but as the slow accrual of evidence. Marin, who had navigated the face and pyramid debates, insisted on the same ethos. "We should treat these molecules like witnesses in a very old case," Marin said in a public briefing. "They speak, but they do not speak plainly. We must interrogate them with a full suite of tools and with humility. In the labs, instruments that once seemed the stuff of sterile description produced scenes of almost cinematic intensity. Gas chromatographs split mixtures into components. Mass spectra appeared like fingerprints, peaks rising and falling with chemical precision. Analysts compared fragmentation patterns against databases of terrestrial organics and against synthetic compounds that could indicate non-biological processing. Each match or mismatch altered the probability landscape. The presence of certain chlorinated organics raised eyebrows. On Earth, chlorinated compounds can be industrial artifacts, but they can also form in natural reactions under certain conditions. The team flagged every anomalous compound, aware that false positives can be as misleading as false negatives. It was also a moment of procedural self-awareness. Spacecraft themselves carry organics, even with rigorous sterilization, residues remain. The team had to ensure that what they detected did not come from their own hardware. Cross-checks included blank runs, analysis of unused consumables, and comparative studies of regions far from the anomaly. The instruments were, in their way, detectives trying to tell apart native testimony from planted clues. Beyond chemistry, the question unfolded into comparative reflection. How do Earth's monuments, its organic signatures, and their preservation inform how to read Mars? On Earth, human structures can leave chemical footprints, soot, copper corrosion, deposits of unusual alloys that reveal technological processes long after the habitations are gone. If Mars bore artifacts, what kind of chemical legacy would those artifacts leave across deep time? Metals corrode differently in different atmospheres. Glass devitrifies. Organics either polymerize or break down. The team ran experiments that mimicked Martian diagenesis. Were certain polymers or mineral phases durable across millions of years under Martian-like radiation and desiccation? The answer was sobering. Many organic structures degrade beyond routine recognition. Only a few classes of biomolecules, certain refractory lipids, geological macrostructures, mineralized microfossils, carry a long-term survival bias. Human experience on Earth also offered cautionary tales about attribution. Methane in the atmosphere has many sources: industrialized landscapes and wetlands, both active and ancient. A simple correlation of methane with an anomalous formation on Mars would not by itself prove causal connection. On Earth, the presence of methane near a ruin could mean that the ruin trapped decaying biomass, or that microbial communities have recolonized a sheltered niche. The work on Mars required analogical discipline. Borrow the patterns that are informative, not the stories that are comforting. The larger cultural reflection returned, as it tended to do, to questions of deep time and fragile memory. Methane, ephemeral and reactive, is a fleeting memory, a faint exhalation that might not persist. Its detection suggested recent events relative to geological scales. That immediacy held special weight. If organics persisted, they were signals that the planet's history had not entirely been scrubbed clean by time and oxidation. And if those organics aggregated around geometries that hinted at deliberate shaping, the discovery would force humanity to reckon with a different kind of continuity. The possibility that intelligence crafts durable traces, that the idea of monumentality is not exclusively terrestrial. Speculation, however, remained disciplined. Every potential path, abiotic hydrogenation, thermogenic release, methanogenic life, or a byproduct of some ancient technology, carried testable predictions. Life would likely produce specific isotopic signatures, and an association with other biomarkers, serpentinization, would pair. Methane with hydrogen and certain oxide minerals, thermogenesis would bring heavier hydrocarbons into the mix. The team designed missions to test these forks, building experiments around the predictions rather than the wishes. Ethics recurred as a practical compass. The planetary protection rules were not abstract, they were operational constraints that shaped mission architecture. Preserving potential biosignatures meant trading speed for care. Each sample taken had to be documented and contained. If an anomaly were near a formation that could be artificial, international deliberation would be necessary. The team began drafting frameworks for collaborative stewardship, international panels, open data protocols, and staged sampling guidelines designed to minimize irreversible interference. At the emotional level, the discovery of methane reshaped the team's disposition. Where previous anomalies had taught them to be wary of yearning, to guard against turning pattern into myth, this molecular whisper invited a different posture, a patient optimism. The cautious joy of possibility settled alongside the sober fear of contamination and of misattribution. "We are learning to be small before the evidence," Marin observed in a technical briefing. Not small in surrender, but small in the sense of recognizing how large time and geology are compared to our stories. The comparisons with Earth remained not merely methodological, but moral. On Earth, methane unrolls into human narratives, wetlands and war zones, industrial leaks and pastoral futures. It teaches about cycles and disruptions. On Mars, methane's episodic presence is a clue to processes that could have been hospitable long ago or that sustain minor hidden niches today. Its detection would not, by itself, rewrite humanity's place in the cosmos, but it would deepen the ledger in which the planet's past is written and would sharpen questions about preservation, memory, and responsibility. In the end, the measurement of methane was another inflection in the unfolding story of seeing. It was a molecule that demanded evidence assembled across instruments, disciplines, and ethical frameworks. It demanded patience in the face of public appetite for revelation and required international restraint where curiosity bristled. It required the human mind to hold desire and doubt together, to be ready for the profound and the prosaic in the same breath. So the team collected more data, planned more passes, and drew careful lines around the plane, lines that were not of certainty but of inquiry. They compared the plume's chemistry to Earth's seeps and to lab experiments. They refined sterilization techniques to guard against false trails, and they convened ethicists to prepare for choices that might have planetary consequences. The detection of methane and the discovery of organics in the vicinity of the anomalies did not provide an answer. Instead, it widened the question, offering a fresh axis for comparison with Earth, not simply to ask whether Mars had life like ours, but to learn how to read the fragile residues of time, geology, and possible agency in a planet whose memory had been written and rewritten across billions of years. The plane remained mute and patient. Molecules rose and dispersed. Instruments caught whispers and translated them into graphs. Human beings, listening from a distance, learned anew that the work of deciphering deep time is not a sprint, but a long, collaborative apprenticeship, an exercise in humility, rigor, and imagination that honors both the chemistry of a molecule and the ancient possibility that the cosmos keeps its secrets in the smallest of signatures. What did it mean to call a stonework impossible? How had humans, for centuries, stood before monuments on their own planet and assumed that the hand behind them must be more than mortal, an intelligence elevated beyond the common reach of nature? The question hovered now over Mars, not as a simple analogy, but as a methodological mirror. If Giza and Teotihuacan once provoked claims of the inexplicable, if the Nazca Plains compelled readers to ask whether straight lines and spirals were the handwriting of ritual mind, then Mars presented the same temptation at a planetary scale. Could the red planet's most arresting shakes be the distant echo of our maker? The history of how civilizations confronted their enigmatic ruins on Earth was instructive because it was not merely a chronology of discovery, but a lesson in cognitive habit. On the Nile, long before modern archaeology brought stratigraphy and radiocarbon into the conversation, the sight of perfectly aligned blocks and corbelled chambers had produced mythic explanations, gods, kings, and otherworldly builders. Later, as excavation methods matured and context was recovered, the story of the pyramids became not a tale of inscrutable engineers, but of labor, logistics, religious economy, and centuries of accumulated practice. Similarly, the Nazca lines of southern Peru, enormous geometric drawings visible from low-flying vantage, had been variously explained as astronomical calendars, rituals for rain, or messages to gods in the sky. Where outsiders had once assumed impossibility, archaeologists found a spectrum of human behaviors, ritual landscapes, coordinated labor, and social choices about what to mark and why. This terrestrial archive of misattributions corrected, of wonder rechanneled into method, was not an argument against being surprised. It was a template for a disciplined surprise. The essential lesson: extraordinary-looking forms on a planet do not always, or even usually, require extraordinary causal agents. Complexity of form can be generated by simple processes given long time. But that lesson had two parts. The first was methodological humility, insist on context and on the slow accumulation of evidence. The second was imaginative rigor, enumerate what an engineer or an artisan would have to do to produce a structure that persisted across the eons. Merron thought of these two parts the way a conservator thinks of varnish and canvas. In the labors of planetary investigation, they were not opposed. They were complementary disciplines, one preventing premature myth, the other sharpening the set of questions that would distinguish artifact from accident. "Look at Giza," a colleague said once during a late-night briefing, voice rough from caffeine and the hum of fluorescent lights. The reference was not rhetorical. They unrolled a high-resolution orthophoto of the plateau and then juxtaposed it with an orbital mosaic of a Martian plain. The pyramids are geometric, but they sit in a rich archaeological context. Tombs, cemeteries, tool marks, inscriptions. Those associations are what turn architecture into evidence of agency. The implication was clear. Shape alone is insufficient. Context, inclusion, stratigraphy, tool traces was what turned an ambiguous geometry into cultural testimony. The team performed a quiet exercise in comparative taphonomy. On Earth, they noted, monuments persisted because of choices about material, site selection, and redundancy. The ancient Egyptians quarried limestone and granite from recognizable strata, chose arid environments that slowed biological degradation, and built at scale that outlasted petty reuses. The Nazca lines survived because they were made by removing a thin, dark surface patina to reveal lighter ground beneath, an economical technique set in a landscape with little wind or rainfall to erase the contrast. In both cases, survival was a function of environment meeting method. Equally important were human maintenance practices. Monuments were reinscribed by later generations, repurposed, and sometimes intentionally preserved by succeeding cultures. Mars posed constraints that demanded thought experiments about survival strategies. The planet's thin atmosphere and intense ultraviolet radiation, its history of oxidation, and its long epochs of aeolian abrasion mean that only some kinds of march would persist in legible form. Carving an intricate bas-relief into a soft, weathered stone would be folly. What survived had to be either massive in scale, composed of extraordinarily resistant materials, or protected by burial and later exhumation. If some intelligent maker had wanted to leave a message that could be read across deep time, what kinds of strategies would have the highest probability of surviving? The answers were sobering and practical. First, scale. Very large geometries were comparatively robust. A kilometer-scale alignment of raised ridges or an arrangement of hills in a precise grid had a far better chance of surviving. The abrasive effects of eons than a surface painting or a delicate carving. Second, material choice. Targets composed of refractory minerals, siliceous rock, certain types of igneous outcrop would resist chemical decay. Third, redundancy and repetition. Multiple markers, repeated across topography, reduce the risk of total erasure by localized events. Fourth, leverage of geological processes. An intelligent agent might use existing resistant structures, dike swarms, basaltic flows, as canvases, arranging or truncating them rather than attempting to import materials or labor at planetary scales. These considerations were not merely speculative. The team formalized them into a design space analysis. They built probabilistic models that asked, given Mars's erosional regime, what was the survival probability of various marker types after 10 million, 100 million, and 1 billion years? The output was stark. The structures most likely to be preserved were those that either exploited large-scale geology or were constructed at scales approaching tectonic features. Small-scale craftsmanship, the sort of thing that would survive human political centuries, tended to vanish into the regolith. There was a secondary axis that complicated the calculus: recognizability. A marker might survive but be inscrutable. Erosion could transform intended angles into rounded arcs. Differential deposition could mask relational distances. Dust mantle could obscure the contrast between marker and ground. An ancient walkway, overlaid and refilled by wind, might become a low relief that only a high-resolution topographic survey could detect, and a long-evolved observer might no longer perceive its repetitive logic. Recognizability, therefore, was not the same as durability. The two together determined the detectability of a message. The team's analog work on Earth deepened the insight. They walked desert landscapes where pre-Columbian roads lay beneath wind-blown sand. Aerial imaging revealed rectilinear patterns that were invisible at ground level. They surveyed glacial moraines where rhythmic sedimentation generated geometric repetition so convincing that locals once told legends of human plan. The exercise taught a crucial interpretive discipline. Evidence of agency rests on multiple scales and modalities. A mark could be durable and yet ambiguous. It could be unambiguous only when material signatures, metals, constructed foundations, tool marks, accompanied geometry. It was here that the conversation returned, predictably and necessarily, to the paleontology of material culture. On Earth, metallurgical residues, processed glass, and complicated ceramic assemblages are durable traces of technology. Yet Mars's geochemical theater had different chemistries. Metals oxidize, glass devitrifies, organics break down under ionizing radiation. The team debated which materials might leave the most diagnostic signatures after hundreds of millions of years under Martian conditions. Certain minerals, specific oxides, unusual crystalline phases, and isotopic anomalies emerged as the most promising. A concentration of an alloy with an isotopic fraction that could not be explained by planetary differentiation would be, in principle, a smoking gun. So would processed ceramics with firing signatures that implied elevated temperatures and controlled atmospheres. Marin, who had shepherded the team through earlier episodes of Face and Pyramid, phrased the methodological shift plainly. We have to stop asking whether the shapes look impossible and start asking what it would take to prove impossibility. What instrument, what sample, what isotopic ratio would force us to accept agency? And then we pursue those measurements, not the twitterable geometry. There were moments when the team rehearsed language for public engagement, aware that cultural appetite for sensational claims could outpace the slow, stubborn work of evidence. The Council of Scientists agreed on a rhetorical protocol. When geometry was suggestive, speak of plausibility and degrees of confidence. When material anomalies appeared, publish the raw spectra and invite independent reanalysis when a lander was proposed. Frame it as an archaeological and geochemical mission, not a rescue of myth. These are small acts of civic pedagogy, every press release a brush against centuries of human storytelling habits. Yet the social history of misattribution demanded a more pointed cultural reflection. Many earlier claims about Earth's monuments had been inflected by colonial narratives, outsiders who could not conceive that local. Societies had the sophistication to produce geometry and math on the scale of pyramids. Those assumptions had slowed scientific understanding and mischaracterized agency. The archaeologists in the team insisted on ethical vigilance in searching for makers on Mars. Scientists must not replicate imperialist logics, assuming that only certain kinds of minds could have produced certain forms. The work of interpretation must be pluralistic, open to diverse models of cognition and effort. There were also practical constraints that grounded the conversation in engineered time. Remote sensing could reveal promising targets, clusters of angular mesas, anomalous metallic spectra, or repeated geomorphological motifs, but only in situ study could test material culture hypotheses. Landing, drilling, sampling, and returning materials to terrestrial labs were expensive and politically laden. The decision to prioritize a site for a lander was therefore a public choice, mediated by budgets, international cooperation, and ethical guidelines related to planetary protection. The team designed mission concepts that staged investigation, a reconnaissance orbiter, a light lander to perform non-invasive surface chemistry, and a later, larger mission that would sample with sterile tools under international oversight. Throughout the planning, the specter of hoax and self-deception lurked as a cognitive hazard. On Earth, misreadings, deliberate forgeries, and wishful thinking had all shaped archaeological narratives. The team instituted a culture of preemptive skepticism. Every positive anomaly required at least 3 independent lines of evidence: geometric, compositional, and structural. If a putative marker failed any of these axes, it would be shelved as a tantalizing curiosity rather than elevated to extraordinary claim. The public sphere, predictably, spun its own fictions. Commentators recycled images of familiar monuments, Giza, Stonehenge, the Nazca lines, over Martian frames, producing collages that blurred analogy into assertion. Conspiracy theorists invoked suppression, enthusiasts built speculative reconstructions, and artists used the ambiguity for narrative play. The team responded with patient communication, layered visualizations that showed scale, contour, and composition amalgamated with transparent uncertainty bands. The aim was not to crush wonder, but to teach a longer patience, the kind that allows evidence to congeal slowly without being hijacked by immediate narrative. Philosophically, the debate about monuments on Mars turned inward. What did it mean, existentially, to find or to lose the evidence of another mind? The human desire to discover kin in the cosmos is old and powerful. Monuments are deliberate attempts to transcend mortality, to inscribe a voice across time. The possibility that a mind somewhere else had attempted the same gesture, a geometry to be read by unknown eyes, was emotionally freighted. It promised continuity, but it also raised a terrifying contingency of fragility. If an intelligence could be erased by time, by climate, by planetary change, then human beings were not exempt from the cosmic forgetfulness they feared. There was a modest antidote to that anxiety, born of the science itself. The work of discerning agency from geology taught a broader humility about memory. If even the most enduring human monuments are vulnerable to geology's appetite, then preservation required deliberate choices. Redundancy in record-keeping, distribution of archives across multiple environments, and the crafting of messages that exploited planetary processes to enhance survival. The team wrote the idea into grant proposals. If humans wanted their own records to survive deep time, what strategies could ensure that persistence? The question folded the search for Martian makers back into a design problem about human legacy. As the season of observation closed and data were banked for long-term study, the team produced a synthesis. The presence of monumental geometry should be treated as an invitation to a set of targeted, interdisciplinary inquiries. Geometry alone could not be proof. Material anomalies could be decisive only when repeated, contexted, and independently verified. The protocol that emerged was conservative but generative. Use geometry to triage, use composition to escalate inquiry, and use in situ sampling under international stewardship to adjudicate claims. If the comparison to Earth's ancient monuments did anything more than caution, it reframed the Martian question in a way that mattered ethically and epistemologically. The story of Giza and Nazca was not an argument against the possibility of makers elsewhere. It was, instead, an argument for a method of looking that combined imaginative richness with procedural discipline. It taught that the seduction of presumed impossibility could be redirected into careful tests that enriched understanding regardless of outcome. In the end, the monuments on Earth had taught humanity how to be patient with its questions. They had shown that wonder does not have to become mythology, that stories can be provisional frameworks guiding more detailed work. On Mars, the same temperance was required. The red planet might hold shapes that, at a glance, felt engineered, or it might display the deep grammar of physics and chemistry masquerading in forms that the human brain reads as intentional. Either conclusion would enlarge knowledge. Either conclusion would change the ledger of human thought about deep time, memory, and the endurance of signs. Marin folded the final report into the archive with the quiet satisfaction of someone who had watched a conversation mature. The report did not promise revelation. It offered instead the scaffolding of inquiry, a roadmap for how to move from motion shaped by imagination to method shaped by instruments and discipline. The lesson was not the denial of romance, but the cultivation of a habit that could carry romance across long, patient work. When the cameras of the Puvet microscope moved on to newer, glossier provocations, the team continued, in quieter cycles, to gather the evidence that alone could answer the biggest of human questions. The comparison between Mars's enigmatic plains and Earth's ancient monuments remained a living lesson. It asked observers to hold desire and doubt together, to honor both the ache for continuity and the slow, demanding arithmetic of proof. In that double hold lay the ethical heart of exploration, to look with care, to excavate with humility, and to tell the public what was known and what remained to be known, so that the future, when it read these lines in a different light, might find a record made with the patience that deep time requires. Can the patient violence of wind and ice become, in the right light and after the right winters, indistinguishable from the work of a mind? That question settled on the team like dust, slow, persistent, and impossible to ignore. It was not the romantic question of conspiracy or fantasy. It was the quieter, more dangerous one. Could a catalogue of natural processes, operating over millions of years, assemble a morphology so precise and so repeated that it fools a civilization into reading intention where there was only physics? The answer, as the team learned, was both simple and maddeningly complex. Many of the anomalies could be given plausible geological biographies. Each hypothesis, wind abrasion, ice dynamics, dust deposition, thermal fracturing, worked well for particular features. None on its own, yet explained everything. The incompleteness of those explanations was the story's core now. How good science built plausible worlds of cause, and how, at their seams, questions persisted. At first, the explanations came like tools from a well-worn kit. Aeolian processes, the slow, almost surgical action of particles driven by a thin but persistent atmosphere, carved linear grooves, sharpened edges, and left yardangs that from orbit read like walls. Thermal stress fractured basalt into orthogonal blocks, creating rectilinear scarp systems that could be mistaken for corners or foundations. Sedimentary layering, deposited in repeating cycles under ancient lakes or episodic floods, later weathered into concentric terraces that imitated rings. Lava flows cooled and contracted into polygonal joints, their outlines sometimes abutting in regular patterns. Ice, whether ancient glaciers or buried lenses, created patterned ground when it sublimated or melted, leaving behind networks of cracks and troughs. The labors of the scientists were to turn each of those possibilities into testable narratives. They used their instruments to ask specific questions of the rocks. Is there evidence of cementation consistent with aqueous deposition? Do radar returns show internal layering, voids, or homogeneity? Does thermal inertia suggest coarse clastic fill or fine-grained dust? Can isotopic ratios of carbon and oxygen be reconciled with abiotic mineral formation, or do they bear the fractionation signature of biology? Each test narrowed possibilities, but also revealed new ambiguities. Marin watched that process with a mixture of professional relish and private unease. On a long, fluorescent-lit afternoon, Madden stood at the processing console while an imaging specialist ran a comparative filter. Set across a mosaic. Look at the granulometry along this rim, the specialist said, tapping a cursor. The reflectance curve shifts where the slope changes. Coarser clasts, possibly lag deposits. That argues for inverted channel interpretation, not construction. And yet, Marin replied, leaning forward until the light cut across their cheekbones, why would the clast armor maintain such regularity across 3 concentric elevations? It's the same mode repeated too closely to be entirely random. There was a pause. The team had learned how to name their discomforts aloud, run the thermal inertia through the orbital diurnal model, but also cue the radar tomography. If the radar shows sediment-filled basins with a repeating lens sequence, we can plausibly reconstruct depositional cycles. Those methods, measure, model, repeat, became rituals. In the labs of analog study, graduate students crawled over badlands and basalt flows. They measured corner angles and scour marks, sampled cementation horizons, and mapped joint spacing and dike swarms. They sent bulky crates of sieved sands to freezers where simulated Martian winds and ultra-cold temperatures would comb grains. Across ages and accelerated time, engineers built scaled bed forms in a wind tunnel that could vary particle size, gravity equivalent, and atmospheric density to approximate a thin Martian breeze. Geochemists poured olivine into hydrothermal reactors and watched, in hours or days, what on Mars took eons, serpentinization, hydrogen release, the slow alchemy that can generate methane without life. Those experiments produced answers and caveats. Wind could produce remarkable linearity if it was guided by an underlying structural grain, pre-existing faults or joints that dictated where erosion took hold. Ice could carve terraces when a buried glacier retreated unevenly, leaving concentric moraines that, after differential erosion, read as geometric rings. Sublimation of subsurface ice could collapse ceilings of lava tubes, forming long, straight troughs that maintained azimuth because the tubes had followed dike intrusions. The combinations were numerous: wind atop joint sets, atop seasonal ice cycles, atop variable lithology. The permutations proliferated like dust devils, but there remained recalcitrant observations. In some places, the regularity persisted across modalities. The visible imagery showed sharp rings. Radar suggested internal layering aligned with the rim. Thermal maps revealed consistent. Radial variation in conductivity suggesting different grain sizes or cementation, and multispectral indices hinted at compositional changes confined to the rims, where several instruments sang together. The case for a purely blind geological origin weakened, but did not vanish. Plausible but unusual geological histories could be constructed. The recreations were not implausible. They were improbable, and the difference was everything. Inside the control rooms, the mood oscillated between methodical calm and a kind of vertigo that felt almost theological. "We are not looking for gods," Marin reminded the team at a briefing, "but we must also not be intellectually deaf to the possibility that nature occasionally composes with unusual fidelity. Our job is to honor both senses." The team laughed, not triumphantly, but in release. They were scientists, trained in the economy of doubt. They were also humans who responded to patterns and narratives, dialogues threaded through the workflow. The geophysicist argued for tectonic inheritance. Look at the fracture maps, she said. Regional stress fields put a directional bias across that province. The grooves are where the crust was weakest, the geomorphologist countered, but then explained the concentric terraces. Why would erosion carve repeated rings unless there were cyclic depositional events? The archaeologist turned planetary analog, an unusual role that had emerged in the cross-disciplinary teams, cautioned, and remember preservation bias. If someone or something wanted a message to survive, they would exploit existing geology. But even then, the message must also be legible to a different perceptual system. Those debates were long and granular. They were also the research community's moral incubator, teaching how to hold ambiguity with intellectual rigor. Not everything could be resolved by better images or deeper models. The instruments themselves had limits that kept stubborn questions alive. Radar penetrated dusty veneers but lost resolution at certain depths. Spectrometers could identify broad mineral families but sometimes could not discriminate between clays formed in a lake and clays altered by volcanic hydrothermal fluids. Instrument noise and calibration drifts introduced faint echoes that could masquerade as features. Selection bias was real. The places chosen for intense scrutiny were often the most imageable, not necessarily the most representative. And there was the human bias to consider, what the team increasingly referred to as the historiography of seeing, prior metaphors, cultural expectations, and the gravitational pull of story-making that nudged interpretations toward familiar analogies. These limitations led to procedural inventions. The team wrote algorithms to test for cognitive bias in image processing, multiple pipelines with deliberately divergent priors, blind reanalyses where analysts did not know which sun angle corresponded to which strip, and independent replication by teams on other continents. They posted raw datasets publicly to invite community scrutiny, an uneasy but necessary concession to transparency that sometimes accelerated both productive critique and spurious speculation. Marin oversaw a public communication protocol. Publish the data, he said in a recorded briefing, and the uncertainties. Let the public into the method. Wonder is not the enemy of rigor. The emotional register of the work was subtle and persistent. Scientists felt delight when hypotheses held across modalities and deep frustration when an elegant model unspooled under scrutiny. There were nights of near ecstatic discovery, a thermal anomaly that matched a radar echo and suggested buried ice lenses whose sublimation would naturally explain both rings, and associated methane episodicity. There were days of flat disappointment, an assumed archaeological marker resolved into a jointed lava plateau. The rhythm of thrill and deflation charmed some and tired others. Yet the team learned to value the long arc of careful accumulation papers shelved only to return months later with new data that revised the calculus. Public pressure was another variable that bent the arc of inquiry. Media cycles wanted definitive pronouncements. Donors wanted clear deliverables. Marin kept repeating a phrase until it was carved into the lab's culture. Extraordinary appearances require cumulative convergence. That phrase became the team's compass. It shaped proposals, the sequence of observations, and even the rhetorical style of press releases. In the field, analog work deepened empathy for ambiguity. Visiting Earth's periglacial landscapes, researchers watched polygons form, collapse, and reform as thaw and freeze-driven processes rearranged the ground. They walked riverbeds turned to ridges by inverted channel processes. They stood by coastal calcarenite platforms whose regular notches only made sense when one understood differential cementation. Those landscapes taught the team that mindless processes could craft complex grammar given the right conditions, and that human eyes could be profoundly misled when scale and context were absent. It was a caution grounded in experience. Do not overprivilege pattern, privilege explanation. At the same time, the ethical stakes of action grew sharper. The presence of methane and the hint of organic chemistry discussed in previous campaigns made preservation a paramount concern. If buried niches preserved organics, aggressive sampling risked irreversible loss. The team debated protocols, minimal invasive sampling, strict sterilization, staged sampling with independent oversight, and international forums to adjudicate controversial moves. These conversations were not theoretical. They shaped mission architectures, payload designs, and the cadence of proposals. Instrument teams designed sampling brushes and sealed sample caches more carefully than ever, aware that a misstep could contaminate the record forever. Despite best efforts, many anomalies refused tidy explanation. Wind and jointing could explain much. Ice dynamics explained terraces and certain troughs. Sapping and channel inversion accounted for many linear ridges. But there remained places where several processes would have to conspire in improbable concert. Those places accumulated in a list the team called puzzles, brown folders on a shelf, each thick with a different modality: radargrams, thermal maps, isotopic plots, and field analog notes. The puzzles became the engines of inquiry, focusing limited resources on targeted in-situ tests. When the team proposed a modest lander to sample one of those puzzles, debates rippled through agencies and funding boards. The policy question was not only scientific, it was cultural. Who would decide what could be touched? What values guided preservation versus retrieval? The ethicists argued for distributed stewardship, multinational teams, open data covenants, and a staged chain of custody for any returned material. Those proposals were aspirational and hard to finance. Yet they reframed the work. It was no longer a narrow hunt for answers, but a practice of care. Marin's leadership style matured in that climate. He learned to be both cautious and courageous, to withhold headlines while securing the resources for patient inquiry. He wrote grant justifications in a voice that married wonder and restraint. "We will not promise revelation," he told reviewers, "but we will promise method." The line secured skeptical funders and mollified anxious publics. It also kept intact the team's ethical spine. The deeper lesson, repeated through nights of reprocessing and analog expeditions, was philosophical. Time is the slowest and most ruthless agent. It democratically erases the trivial and sometimes spares the accidental. A pattern that looks engineered may simply be the improbable survivor of conditions that favored its persistence. The human urge is to prefer narrative continuity, to find kinship across the void. Science, however, insists on layered evidence. Geometry thrills the eye, composition anchors an argument, stratigraphy grounds a hypothesis. Only when these lines of evidence converge can a claim stand firm. And yet convergence remained elusive. The more instruments they engaged, the more complex the answer became. Wind could explain the corners of one mesa, ice explained the terraces elsewhere, dust mantles altered spectral signatures and hid compositional truth. Subsurface dikes channeled collapse to create linear troughs that, from above, read like canals. The upshot was an uneasy plurality, many convincing local stories, no single planet-spanning narrative. The planet's grammar was not simple. It was a lexicon of processes that occasionally arranged into syntax humans found readable. The public found that answer unsatisfying. They wanted a story, a revelation, a headline. The team learned to accept that their work, often slow and grainy, would disappoint some and enthrall others. Marin used that tension as a teaching point in public lectures. The most honest answer is often the least cinematic, they would say, but it is the one that survives better scrutiny. That was an admission of modesty and of method, an insistence that the beauty of inquiry lies in the ability to live with open questions while steadily closing them. In the end, the scientific hypotheses, wind, ice, dust, lava, and chemical alteration, remained powerful and mostly sufficient for many features. They created plausible biographies for rings, grooves, and terraces. Yet they did not yet close the case. Small mismatches lingered at the edges of datasets. Unusually precise geometries persisted in places where the models expected noise. Compositional anomalies nodded toward processes that were hard to explain with known geology alone. Those mismatches were not proof of agency. They were invitations to better instruments, bolder in-situ tests, and a patient, international practice of stewardship. The narrative that emerged for public consumption was intentionally provisional, an account of compelling possibilities, not certainties. The team published its datasets with careful commentary, invited open replication, and proposed a sequence of follow-up missions designed to interrogate the most puzzling features with sterilized, careful hands. Marin and colleagues framed their work in a larger story, one about deep time, fragile memory, and the humility required to read planetary palimpsests. They reminded audiences that the cosmos kept its stories in subtle deposits and that human patience was required to decode them. There was solace in that. The science did not always deliver the drama the public craved, but it offered something steadier, a method for truth that could, over decades and generations, assemble an account of a planet's life. The work was not the cinematic reveal of an alien monument, nor the simple vindication of a geological model. It was the slow accrual of evidence, the careful elimination of error, the construction of robust narratives that could survive reinterpretation. That, the team insisted, was a victory of its own. As Part 10 closed, the fold of unanswered questions remained. The geological actors, wind, ice, rocks, and dust, had convincing parts in many scenes. They had not yet acted together in a way that dispelled all doubt. The puzzles endured, and in their endurance they did something the team had come to value. They kept the work honest. They required the next generation of instruments, the next sequence of in situ tests, and the continued stewardship of a public conversation capable of holding wonder and uncertainty simultaneously. The planet waited, patient and mute. Humanity, for its part, prepared to listen longer, measure more carefully, and treasure ambiguity as a guide rather than as a failure. 11. Hypothesis of the extraterrestrial. What would it mean in the arithmetic of history to find not only traces but the trace of intention? The question pressed in like an uninvited light. If Mars once hosted a civilization, or if intelligence from elsewhere had touched its plains and left marks, how would that fact rearrange the ledger of meaning? That single speculative hinge opened a cascade of inquiries, technical, ethical, cultural, and it pulled the team into a new mode of thinking that balanced the thrill of possibility with the discipline of doubt. The room where the hypothesis was debated did not look like a cathedral. It was fluorescent lit, crowded with monitors, and smelled of coffee and solder. Around the table papers lay open, radargrams, spectral plots, model outputs annotated in different handwriting. Marin stood at the display, palms flat on the table, and read the data the way a musician reads a score. The tone in the room was not hysterical, it was quick and surgical, but beneath that precision was an unmistakable current, the human quality of wanting to belong to a larger story. Assume for a moment that these formations are not mere geology, Marin said. The sentence was simple and neutral, a deliberate press against the edges of hypothesis. What minimal evidence would be required to elevate that assumption from plausible fiction to reasonable inference? A pale-faced geophysicist answered first, the practical voice that had learned to translate desire into metrics. Material signatures, reproducible isotopic anomalies, processed alloys, non-natural isotopic ratios. Geometry alone won't do the job. An anthropologist in the room, an unusual role, but one that had become indispensable, leaned forward. And context. On Earth, we don't identify a culture from a lone stone. We need assemblages. Regularity in artifact types, repetition and technique, spatial patterning consistent with behavior. A single pyramid is suggestive, a city is convincing. The exchange was both technical and philosophical. It revealed the hybrid logic that would govern any claim of non-terrestrial intelligence, geometry as a prompt, materials as corroboration, context as the critical multiplier. The team wrote lists on a whiteboard: detectability, survivability, signatures, ethics. Each item branched into sub-items: sterilization protocols, sampling hierarchies, statistical thresholds, public communication strategies. They rehearsed scenarios with the care of people handling volatile chemicals. The first scenario was the Stoic one, an indigenous Martian civilization that rose and fell during a warmer epoch, leaving large-scale works that later survived due to material robustness and luck. The second was visitation, intelligences that arrived transiently, probes, colonists, scouts, leaving artifacts that might preserve better than local biology. The third was hybrid, endogenous markers reworked by visitors, or marks created intentionally to be legible across species barriers. Each had distinct predictions. If a civilization had existed, what strategies might it have used to make a message endure? The team sketched a catalog of durable choices: scale, material choice, redundancy, and exploitation of geological motifs. A kilometer-scale motif exploited topography. Refractory minerals like certain oxides resisted chemical attack. Repeating markers hedged against localized destruction, and embedding in subsurface structures protected against radiation and wind. If a maker had known anything about deep time and the violence of planetary processes, they would have chosen redundancy and scale. Imagine a language built to be legible across unknown perceptual systems, an exobiologist proposed. Mathematics, prime numbers, ratios, geometry with nested scales like a fractal, because scale invariant designs have a better chance of being recognized by different sensory apparatuses. Marin nodded. The idea had elegance. Simple mathematical constructs are plausible cross-cultural signals, and they are also robust to erosion in some cases. But elegance was not evidence. The team needed to translate these design hypotheses into testable metrics. What would a prime-numbered spacing look like in remote sensing? How would radial ratios survive diagenesis? Statisticians were pressed into service. They translated poetic possibilities into probability thresholds. There was persistent awareness of the error modes. The history of science taught them loudly how desire can masquerade as pattern. The canal myth, the face, the pyramids, these were cautionary tales. The team therefore constructed an operational rule. Extraordinary claims required extraordinary convergence. Geometry would initiate priority observation, compositional anomalies would elevate to in situ sampling, and conclusive inference would require multiple independent lines: geometry, chemistry, structure, and stratigraphic context. At night, the team ran thought experiments that felt like ethical drills. If a lander sampled a rim and found metallic beads in a regular matrix, what then? A call for international deliberation would be mandatory. Discovery would not be a national trophy, but a global inquiry. "We will not be discoverers," Marin said in one briefing. "We will be custodians. Our job is to extract truth without destroying the archive." It was an ethic born of both science and humility. The planetary protection protocols were reinforced not as red tape, but as moral guardrails. Contamination was a practical problem with moral consequences. To introduce Terran biology to an alien archive could erase the trace the world had to teach. The team drafted sampling hierarchies: non-invasive techniques first, then minimally invasive trenching, then targeted coring under sterilized conditions. Each step required oversight, documentation, and a willingness to pause. Public-facing communication became its own discipline. The team devised templates that carefully explained degrees of confidence and the iterative nature of verification. They refused, deliberately, to feed sensational speculation. Marin told a journalist, speaking slowly and plainly, "We are in the exploration phase. We have reasons to look more closely. That is not the same as having evidence of an extraterrestrial intelligence." That restraint did not prevent the press from filling its pages with hypotheticals. Social feeds buzzed with imagined Martian cities and ancient highways. Artists and philosophers turned the hypothesis into a mirror. What would another mind say about humanity if it read these traces? Would it find continuity or extinction? The cultural reverberations were immediate. In living rooms and lecture halls, people embodied different futures, one where humans were not alone in a cosmos of minds, another where monuments were reminders of universal fragility. The team treated such cultural echoes as part of the evidence ecology. Public expectation became a resource constraint. Funding committees, political support, and international cooperation responded to social appetite. That reality did not change their method. It forced them to be even more transparent and disciplined. Probability enters these conversations with a sting. On astronomical scales, the emergence of intelligence is poorly constrained. The Drake-like equations fragment when applied to a single planet with known water episodes and then to an entire galaxy. The team did not indulge in grand claims. Instead, they ran local likelihoods, given the known timescales of Mars's wetter epochs. What is the chance that a sentient species develops and leaves durable traces? The answer was a distribution with wide tails. It allowed neither confident yes nor confident no. There was a quieter and more existential calculus at work as well, a reflection on the fragility of memory. Humanity's archaeological record is young and partial. Cities can vanish in centuries. A stone hallmark can be buried by meters of sediment. The more the team looked at taphonomy, the processes of decay and preservation, the more evident two facts became. First, durable artifacts are a narrow class. Second, the existence of artifacts does not guarantee legibility. One could imagine a civilization with abundant technology that left no trace legible after tens of millions of years. If Mars once hosted minds, their successes and failures might have been invisible on the surface. That possibility intensified the moral bent of the project. If evidence was scarce, they agreed, their duty was to avoid destroying the few potential archives that remained. Stewardship became the animating ethic, the obligation to protect the planet's record so that future generations, perhaps with better instruments or different interpretive frameworks, could read it. The hypothesis of visitation raised additional wrinkles. A probe could be engineered for stealth and longevity. A Bracewell probe, a semi-intelligent emissary left in quiet orbit or parked beneath a rock layer, could have minimal footprint but still preserve data. Detecting such artifacts would likely require different signatures, anomalous thermophysical properties, isolated power sources, non-natural isotopic ratios, or fabricated alloys. The team expanded their detection palette beyond geology and biology to include technosignatures, traces of technology rather than fossils of life. Technosignature science is young and careful. It requires new instruments and new statistical frameworks because the universe of plausible technologies is vast. The team therefore adopted a pragmatic narrowness, search for what is both physically plausible and instrumentally detectable. metals and alloys, persistent thermal anomalies, enclosed cavities with shapes that suggest fabrication, and spectral lines inconsistent with known geochemistry. Even with these constraints, the mind reels. The possibility of an intelligent signature on Mars would reframe human narratives about origin, destiny, and responsibility. The discovery would alter the political economy of space exploration. It would become not merely a triumph of knowledge, but a test of collective ethics. The team rehearsed governance models, international councils to adjudicate handling of artifacts, open data policies to prevent sequestration of evidence, and shared custody protocols to avoid parochial grabs. They also rehearsed humility. A finding that could be framed as extraterrestrial would be scrutinized endlessly. For centuries, claims of otherness have been validated and overturned. The team accepted that any claim must be subject to the hardest scrutiny possible, replication by independent teams, retained samples for reanalysis, and the willingness to revise interpretations in light of new data. The emotional texture of that work was not melodramatic. It was a sustained tension, the small electric thrill of possibility, the heavy responsibility of possible consequences, and the patient work of testing. Marin often reflected publicly that the search for another intelligence was not a race to victory, but a long disciplinary practice. "We are learning a new mode of attention," the scientist said in a widely watched forum. "It is slow, cautious, and collective. If there is a discovery to be made, we will make it better by being methodical." And yet there remained a quiet, persistent fear among some team members, not of beaming signals or hostile interventions, but of the sheer loneliness of negative results. If Mars were shown to have no enduring traces of intelligence, would that respond to the question of cosmic solitude, or simply remind humanity of the ephemeral nature of memory? The cultural sting of absence can be as profound as the bliss of presence. The team tried to frame either outcome as knowledge. Evidence of past minds would be an enrichment of human narrative. The absence of such evidence would still teach the species about the precariousness of legacy and the urgency of preservation. 12. Conclusion. In the end, the investigation settled into a rhythm that was neither triumphalist nor despairing, but resolutely provisional. The formation of hypotheses, the careful testing of predictions, and the slow refinement of methods became the story's heartbeat. The work was not a chase for cinematic revelation. It was a discipline of attention applied to deep time. The planet did not answer in a single instant. Instead, it offered layers, the geometry of its plains, the chemistry of its rocks, the whisper of ephemeral gases, the radar echoes of subsurface structure. Each modality spoke in its own voice. The task of human inquiry was to listen in a chorus, to weigh each testimony, and to assemble a narrative that could be held against the next piece of data without collapsing. The conclusion was therefore not a final verdict, but a set of commitments. First, a methodological commitment. Extraordinary possibilities could not be adjudicated by images alone. They required convergence across instruments and disciplines, from geochemistry to archaeology, from planetary physics to philosophy of science. The team advocated for a staged, investigative pipeline orbital reconnaissance, non-invasive, in situ sensing, targeted, minimally invasive sampling, and, when justified by convergence, broader excavation or sample return, all under international oversight and robust planetary protection. Second, an ethical commitment. The stewardship of a planetary archive is a moral obligation. The discovery of potential artifacts or biosignatures would not be the property of a single nation, corporation, or team. It would be a matter for the global commons. Protocols were proposed. Open data international review boards, multinational mission consortia that aimed to prevent privatization of one of humanity's most consequential discoveries. Third, a cultural commitment. Public appetite for revelation had to be met with rigorous communication. The team developed templates for transparency that avoided both sensationalism and false reassurance. In their discourse, they cultivated a pedagogy of uncertainty, teaching audiences that patience and method were virtues as necessary as curiosity. Fourth, a temporal commitment. The work would be generational. Deep time does not yield to human impatience. The team argued for long-term funding commitments, observatory stewardship, and archival practices that preserve data, instruments, and samples for the scholars of the next decades. They urged humanity to think of planetary exploration as an intergenerational enterprise, one that required persistence even when headlines had moved on. Finally, there was an existential humility, perhaps the softest but most durable conclusion. The search for traces of other minds on Mars was not only a scientific experiment, it was a mirror held up to mankind. It revealed the fragile ways humans store meaning, the hunger for continuity, and the ethical choices that arise when confronted with the possibility of a past other than one's own. Whether Mars bore the fingerprints of another intelligence or not, the processes of looking, of interpreting, and of preserving taught a species about itself, about its appetite for narrative, its propensity for error, and its capacity for restraint. Marin closed the last public briefing with a phrase that gathered many of these threads. Speaking with deliberate calm, the scientist said, "Discoveries that would rearrange our self-understanding deserve the best of what we can be, curious, careful, and generous. We must be patient enough to let the evidence gather, humble enough to revise our beliefs, and responsible enough to protect the record we are privileged to read." That was the ethical chord the project struck. It reframed the search not as a conquest, but as a stewardship. In quieter rooms, the team filed reports, archived data sets, and drafted mission concepts with an almost religious care for metadata. They proposed a small lander with a sterilized microcore sampler, a spectrometer capable of precise isotopic separation, and a sealed sample cache to be entrusted to an international repository. They argued for a multinational oversight council to adjudicate the chain of custody for any materials that might be returned to Earth. The plans were bureaucratic and boring, but they were essential. Out in the public, artists continued to imagine cities on the Red Plain. Philosophers continued to debate the implications of a signal. Children drew Martian faces on homework sheets. The cultural life of the idea persisted, even as the labors of science went on, less visible but no less consequential. The larger lesson, the team hoped, would be durable. To look at another world and to ask whether it hosted intelligence is not only to seek companionship in the cosmos. It is to learn how to read silence, how to honor tiny chemical whispers, how to interpret geometry without gullibility, and how to preserve fragile records against the inexorable appetite of time. In those practices, humanity discovered a form of reverence for the persistence of matter, for the slow arithmetic of erosion and deposition, and for the ethics of caretaking beyond immediate self-interest. The search continued, patient and meticulous. Instruments swept planes at changing sun angles, radar unfurled subterranean maps, spectrometers sampled plumes, and proposals became projects. The questions did not dissolve into certainty. Now! They simplified into better questions. They refined the methods for asking. If there was a single luminous conclusion, it was this: to be a species asking such questions is already to commit to a form of humility. The scale of time that erases monuments is the same scale that invites guardianship. Whether Mars held the relics of another mind, or only the eloquent grammar of geology, the act of asking changed how humanity looked, with more care, with more restraint, and with a deeper awareness of its place in an ancient cosmos. A planet's lines and rings, its grooves and plumes, remained indifferent to human longing, but their study had consequences for human responsibility. The work of interpreting them, careful, collaborative, and ethical, became in itself a kind of answer, that humans could learn to look with the endurance that deep time demands, to hold wonder and skepticism together, and to tend to the fragile traces that might, one day, reveal whether the universe keeps other minds within its long, mute memory. Part 12. The unresolved question. The question remained, stubborn and patient, after decades of images, spectra, models, and missions. What if there was still no single decisive answer? That silence was not emptiness. It was a dense, ornate absence, a field of data and a tangle of interpretations, each plausible in part, each insufficient in whole. The strange structures on Mars had become, by now, less a puzzle to be solved in a single act, and more a long-running conversation about evidence, memory, and the ethics of looking. In that conversation, closure had ceded space to stewardship. Across control rooms, university labs, and policy offices, the work continued in a rhythm that resembled both ritual and apprenticeship. Instruments were the immediate actors. Orbiters swept the planes with new angles. Radars pinged beneath dust. Spectrometers probed for minutiae of composition, and gas sensors traced molecules that rose and fell like breaths. But the human element, the posture toward uncertainty, had shifted into the foreground. Scientists spoke in journals and meetings, not in final proclamations, but in graded probabilities and layered confidences. The language of certainty had been replaced by the grammar of stages, anomaly, candidate, convergent evidence, in situ test. That grammar was deliberate. It was a hedge against the seductive finality of headlines. Marin's presence in the archive had become emblematic of this shift. not as the hero of revelation, but as a steward of method. Marin's reflections were recorded and circulated, not pithy pronouncements, but careful expositions of thresholds, what would count as decisive, which combinations of geometry and chemistry would move a hypothesis from plausible to probable. The scientist's notes traced a map of evidence, a concentric set of criteria that began with cross-modal geometry and culminated, if at all, in uncontaminated, reproducible material signatures. It was a strict ladder, designed to prevent the rush from wonder to claim. That ladder produced consequences for how missions were planned. Priority lists were redrawn according to composite indices rather than photogenic images. Sites that once attracted attention for their dramatic shapes now competed against locales where subsurface chemistry suggested longer-term preservation of organics. The calculus blended the practical with the ethical. What could be sampled without irreversible disturbance? What required international consensus? Which observation windows were fleeting because of orbital mechanics? The work became patient in a way that respected the timescales it was trying to read. The instruments themselves bore witness to complexity. A feature that looked geometric in visible light might show layered heterogeneity in radar, a ring that cast a perfect dawn. Shadow could present spectral signatures of hydrated minerals on one day and dust-muffled basalt on another. Methane plumes continued to appear and vanish with an episodicity that argued against steady, global processes and toward localized reservoirs or transient geochemical reactions. Each dataset amplified nuances and erased clean narratives. In practice, the investigation became an exercise in convergence. Look for the places where multiple, independent modalities told the same story. Yet convergence was rarely absolute. There were regions where geometry, radar, and chemistry lined up to an unusual degree. 3 concentric rims with internal stratigraphy, grooves whose planform straightness resisted simple tectonic explanation, thermal anomalies that mapped to subsurface layering. In those cases, the team escalated the inquiry, higher frequency radar, denser sun angle coverage, targeted thermal sweeps, and proposals for landers with sterilized microsamplers. Those proposals carried a new kind of language, not triumphalist, mission manifests, but stepwise, conservative plans that prioritized preservation over immediate extraction. A new institutional architecture emerged around that ethic. International working groups convened to draft stewardship protocols. These groups were diverse by design: planetary geologists, exobiologists, archaeologists, ethicists, legal scholars, and representatives of diplomatic bodies. Their mandate was not to speculate about what might be found, but to lay out procedures that would be robust in multiple possible futures. Decisions about sample custody, data transparency, chain of evidence standards, and contamination control were not left to agency discretion. They became shared commitments, codified in agreements that borrow from both heritage conservation and biosafety practice. The public conversation adapted to the new tempo. Where early coverage sought imminent revelation, later reporting became more nuanced. Media outlets ran explanatory pieces on taphonomy and isotopic fractionation. Popular programs commissioned documentaries that contrasted the intoxicating visual of a face with the slow, careful work required to read chemical traces. Artists and writers continued to imagine Martian cities, but the cultural conversation matured. The public learned to appreciate the difference between spectacle and evidence. This was not universal. Sensational takes persisted, and conspiracy narratives never fully vanished. But the broader cultural literacy about scientific uncertainty deepened. At the level of method, new tools were developed to reduce bias and increase reproducibility. Image processing pipelines were standardized, with multiple independent teams running blind reanalyses to check for algorithmic artifacts. Statistical frameworks evolved to quantify pattern significance against null models that accounted for the planet's geology and erosional regime. Laboratory experiments simulated Martian weathering in accelerated time, testing how different lithologies and depositional scenarios could produce the apparent monuments under study. Cross-disciplinary fieldwork on Earth became a normative practice. Analog sites were used not to prove identical causation, but to expand the plausibility envelope of competing hypotheses. A consistent theme of these investigations was fragility, the fragility of trace and the fragility of inference. Deep time is indifferent. Large-scale structures produced by natural processes can mimic designed forms, and designed forms can be obliterated by the slender tooth of aeons. An engineered marker intended to last might survive only if it exploited planetary durability, scale, refractory materials, redundancy, or burial. Conversely, the absence of a detectable artifact did not imply absence of intelligence. Many scenarios where society had existed were compatible with nearly complete erasure in the planet's geological record. The team's work, therefore, worried productively at two questions at once: how to detect durable signatures if they exist, and how to avoid conflating pattern with purpose. Ethical dilemmas multiplied as practical possibilities grew. The prospect of in situ sampling raised immediate questions about contamination. Every lander carries a burden of terrestrial organics. Every drill potentially corrupts a pristine microenvironment. The stewardship councils drafted tiered approaches that emphasized non-invasive methods first, then minimalistic sampling under international oversight, and only then, if evidence converged, more invasive extraction. These protocols, borrowed from archaeological conservation, document before touching, preserve matrix relationships, and maintain custody chains for return materials. The goals were not only scientific rigor but moral restraint to avoid the irreversible and thus the unjust. Another layer of deliberation concerned the politics of discovery. If a conclusive signal of intentionality were ever found, who would have the legitimacy to interpret and steward it? The answer, increasingly, was no single nation. The team's proposals envisioned global stewardship mechanisms, multinational archives for returned samples, shared databases, and adjudicatory bodies convened under the aegis of international law. The logic was simple and ethical, and insight of such significance would belong to humanity, not to any political faction. Designing that governance was complex, involving negotiations across scientific cultures and geopolitical interests, but the conversations proceeded with the rare seriousness of a shared planetary responsibility. Technosignature research, once a speculative offshoot, acquired methodological rigor. Instead of searching for exotic artifacts of unknowable design, researchers prioritized detectable, durable anomalies, alloys with non-natural isotopic distributions, thermal anomalies inconsistent with geologic heat flows, cavities with signatures of fabrication or patterns so statistically improbable under geological models that engineering became the simpler explanation. Even these searches were subject to the same caution. Any candidate required multiple, independent lines of evidence and open, replicable data. Throughout this long inquiry, there was a persistent human dimension that never left the labors, the existential resonance of the search. The possibility of another mine somewhere in the solar system reframed questions about continuity and legacy. If an intelligence had arisen and left a mark that endured, that fact would be profoundly democratic in its implications. It would suggest that intelligence is not a fragile fluke, but a force that can imprint planetary geology. If, however, the investigations revealed only the eloquence of geology and the eloquent silence of a world that had never hosted mind, the result would still be instructive, a reminder of how precarious memory is and how rare durable testimony can be. Both outcomes carried moral urgency to preserve humanity's own records with a humility appropriate to deep time, and to nurture institutions capable of stewarding evidence across generations. The teams refined how to communicate these stakes. Public briefings emphasize the staged nature of inquiry, that impressive images are prompts, not proof, that convergent evidence matters, and that in situ sampling must be governed by international stewardship. Educational efforts aim to teach the public about the realities of deep time preservation, isotope geochemistry, and the limits of inference from remote sensing. The intent was not to dampen wonder, but to channel it into patient curiosity and civic responsibility. In laboratories and workshops, the practical work went on. Engineers refined sterilization methods for sampling drills, instrument teams designed spectrometers capable of measuring isotopic ratios with unprecedented precision, mission planners negotiated trajectories and launch windows that balanced scientific value with planetary protection constraints. Funding agencies, persuaded by the measured strategic plans, allocated resources for a sequence of missions designed to escalate carefully, enhanced orbital reconnaissance, multiple non-invasive landers, and, should evidence justify it, a sterilized sample return campaign controlled by a multinational consortium. Alongside these practicalities, the researchers kept a cultural memory of past missteps. The canal debates, the face, and the pyramids had entered public imagination as cautionary tales. Rather than retreat from public engagement, scientists embraced those histories as pedagogical tools. They taught how pattern-seeking is part of cognition and how cultural narratives shape perception. This transparency reduced the allure of instantaneous revelation and fostered a public more attuned to the rhythm of scientific accumulation. And still the mystery endured. Some features remained stubbornly anomalous. resisting neat geological reconstructions, yet also lacking the incontrovertible signatures that would demand an engineering explanation. Those places accumulated in dossiers labeled candidates, each one a concentrated set of data that justified further attention but not celebration. The dossiers embodied the discipline's new humility to catalogue and preserve questions as carefully as one catalogues and preserves answers. In that posture, the search found a new ethical contour. To study another world was no longer merely an expression of curiosity, it was an act of caretaking. Each instrument selection, each mission design, each line of public explanation became part of a longer chain, a chain meant to transmit evidence, intact and interpretable, to future scholars and to publics not yet born. That forward-looking responsibility changed the tenor of the work. Short-term glory was traded for long-term fidelity. The unresolved question itself became, in a sense, productive. It trained institutions to be patient. It taught teams to design for redundancy and replicability. It compelled the development of international governance for planetary stewardship, and it broadened public discourse about the ethics of exploration. The absence of a definitive answer did not feel like defeat. Rather, it felt like an apprenticeship in a new civic skill, how to look at deep time with both wonder and restraint. In the final account, the mystery of Mars's strange structures remained open. Evidence had accumulated in ways that were both terrifying and maddeningly incomplete. The planet had offered hints, geometric motifs that favored further scrutiny, chemical whispers that suggested episodic processes, subsurface echoes that begged direct contact. But none of these hints had yet converged into the kind of incontrovertible narrative that rewrites human self-understanding in A. Single chapter that was not an accidental outcome. It reflected the scale of the question and the conservatism of good method. The team knew that certainty, once claimed, is hard to retract. Better to withhold a headline than to corrupt a record. Better to adopt an ethic that prioritized preservation and transparency than to race for fame. This posture shaped mission proposals, public messages, and the architecture of international cooperation. And so the work continued. Orbiters kept imaging at ever finer scales. Radar arrays pushed deeper beneath dusty veneers. Chemists refined mass spectrometric techniques. Engineers designed sterile coring systems. Policymakers negotiated frameworks for multinational stewardship. The cadence was slow, technical, and necessary. The public watched with renewed patience, sometimes with restless impatience, but often with a developing appreciation for the temporal demands of the inquiry. In the end, the unresolved question was itself a teacher. It taught a species how to read silence and trace faint signatures preserved across eons. It taught humility in the face of planetary processes that can mimic intention. It taught responsibility, that looking can be an act of care, and that discovery, when it finally comes, is best handled collectively and with restraint. Whether the strange structures on Mars ultimately proved to be the fossils of mind or the eloquent grammar of geology mattered less, in some measure, than the way the question reshaped human institutions, ethics, and practices of looking. The mystery remained. It waited on the plain, mute and patient, its lines and rings unperturbed by human debate. Humans, for their part, learned to wait with it, attentive, methodical, and watchful, ready to recognize a genuine trace when the planet finally yielded one, and prepared above all to protect the record that future generations might read. In that discipline, the search for another mind had already altered the human story. The answer, if it came, would be earned in patient increments. Until then, the silence across the red plain was a responsibility as much as a question.